A very good morning to all the dignitaries, faculty members from various colleges and universities, academicians and research scholars from all over India. I, Naboshri Bhattacharya, on behalf of the Research and Development Cell, Amity University, Jharkhand, take the privilege of briefing the previous session we had on recent trends and challenges in research in this faculty development program for 5 days. In the inaugural, we had our keynote speaker, Professor P.K. Singh from Birsa Agriculture University, Ranchi. He shared his valuable knowledge on research in agriculture and also the recent trends. He also guided us regarding various upcoming technologies in the field of agriculture. I heartily welcome our esteemed speakers for this session, Dr. Shantanu Chatterjee, Scientist Doctorate of Information and Communications Technology, DRDO, and Dr. Amit Bhattacharya, Principal Scientist, CSIR. I also welcome our respected Director Engineering, Dr. Vikash Mishra, sir. I also welcome the executive members of FDP, Dr. Joyita Chattopadhyay, ma'am, Assistant Director R&D, AUJ, Dr. Somen Karnar, sir, Associate Professor ASET, FDP Coordinator, Dr. Dhananjay Pandey, sir, and FDP Convener, Dr. Amit Kumar Datta, sir, and Dr. Shantanu Banerjee, ma'am. A very warm welcome to all the respected HOIs, HODs, PLs, and my esteemed colleagues and the participants who have joined us from all over India again. I request Dr. Vikash Mishra, sir, to kindly share his wisdom with us.
Thank you, ma'am. Am I audible?
Yes, sir.
Yeah. Good morning to one and all. My all esteemed colleagues, participants, the expert speaker for the today of the 5-day FDP. I take this opportunity to welcome you all on behalf of MIT University, Ranchi, Jharkhand. And it is my privilege to be a part of this second day, first session of this FDP. And as the topic is itself that is very relevant one, that the recent trend and challenges in research. It is very important if we are into academic fraternity, that research holds a very important position. Rather, it is being said that research is what the core area or is the core product, core services which we have to deliver or any educational institution, be it a college, be it a university. Classroom teaching has taken a secondary thing. It is a byproduct. Usually it is being assumed or it is being said that the classroom teaching is byproduct. Research is the main aspect or the main core which reflects the growth of any academic organization. So it is very important that we should know the criticality, the ins and out, how to carry out a good research. So I am very much sure that this FDP is going to touch upon the various domain on the topic of the research, that how a quality research has to be carried out, in what way one can publish the papers in a good SCI index journal or Web of the Science index journals or Scopus index journal. So it is very important because most of the time what happens that sometimes the academician or the research scholar are not aware of the process, in what way we have to connect, in what way we have to do, or what are the do's and don'ts for carrying out the actual or a very good quality of research. So I'm very much sure that the expert speakers will be touching upon this topic in detail, and it will be a very knowledgeable and a fruitful session for all the academicians. My appeal to all the participants is that make a best use of all the sessions which you are attending and be very sincere that you should not miss any session of the topic. That's my mind. At the end, my best wishes to all the participants and to all the faculty members for a very successful FDP. Thank you, ma'am. Over to you.
Thank you, sir. It is my great privilege to formally introduce our speaker for the second day of the FDP, Dr. Shantanu Chatterjee. Shantanu Chatterjee received the Master and PhD degrees in Computer Science and Engineering from Jadavpur University, Kolkata, India in 2008 and 2016, respectively. He is currently a scientist with Research Center Imarat, Directorate of Information and Communications Technology, Defense Research and Development Organization, Hyderabad, India. He has authored more than 20 papers in international journals and conferences. His current research interests include cryptography and wireless sensor network security. We welcome you, sir. Kindly share your valuable inputs with us.
Thank you, madam, for the brief introduction. It's my privilege also to share my experience, research experience, as well as whatever we have done in network security in our lab with all the faculty and what are the all the participants. So I'll start with my presentation. I think my presentation I'll just share. Is it visible?
Yes, sir, visible. Kindly make it full screen.
Yes, yes, yes. Now it is okay?
Yes, sir. Please continue. Sir.
Okay. So today I want to share that my experience in wireless sensor network security, as well as basically the wireless network security. So my topic is here safe journey of data, and how, why, and when. All these perspectives I want to discuss. So basically we know that wireless environment is we are having a myth that wireless environment is not that much secure compared to the wired environment, because here data is on the open air and anybody can who is smart enough can take the data if it is not properly encrypted, if it is that security models are not followed properly, then anything can happen here. But for wired network, we know that the concept is that it is very difficult that first we tap the wire and we need to take the data. So that is the basic difference. But there are, to apply the security mechanisms for wireless network, we have to have so many security protocols, so many security mechanisms. So those things today I want to discuss. So basically I try to cover the application security, then security issues, and what will be the threat model, then the basic authentication and access control, why it is required. So those things also I try to cover, and then some techniques to verify and validate our security protocols. That there are formal validations as well as informal validations. So both the things we'll try to discuss. Then some of the future research directions. What are the present future scope of research? That also I try to include. And how to securing our IT infrastructure. What are the present challenges and what are the present solutions? And then if time permits, then I try to cover that one of the topic like multi-server authentication and access control and its challenges and solutions. So if you check that this is a diagram for all the wireless technologies, like from WAN to PAN. Means if you check that GCM, 3G, now it is 5G, now 6G is coming. So all those are wireless communications. Then we are coming to WMAN, that is 802.16, that WiMAX and others. Then wireless LAN, 802.11. Then the personal area network, like 802.15, it is having Bluetooth, Zigbee, or near field communications, all those things. But if you check that for all these things, three things are common. One is the endpoint devices, second is the user, and third is the transmission channel. So all this type of network communications is having three key factors: endpoint devices, user, and transmission channel. If we make secure our endpoint devices, then our data will be secure at rest. User means if user is properly authenticated and genuine user are accessing, then user related threats is not there. And transmission channel means when data is on fly, when we are communicating, at that time, if we make it secure, then only we can ensure that at the time of communications, nothing will happen. So how we will do this? That is the challenge. So, so basically that this is a taxonomy of wireless communication security. So here, entire wireless security, communication security, we can divide into three parts, like device security, that is the endpoint related things. Then the communication security, that is the transmission channel, and third is the user. So data or device security is data at rest. When data is not flying, we are storing the data. So that time we need to check about the device authentications. That whatever device is communicating or whatever the sender device and the receiver device, that device should be authenticated first. If the device is not authenticated, then anything may happen. Means some rogue device can come and they can play as an attacker. They can play the role as an attacker. So that problem may happen. Then we have to ensure network access control. Means when device is authenticated, that means that device is joining to the network. After that, we have to check that it is properly communicating or not, and that network it is accessing, that it is having the privilege to access the network or it is not having the privilege to access that network. So that also we need to check. Sorry, one second. Hello? I'm met for a meeting. So, sorry for the interruption. So, that network access control, we are having two things. One is mutual authentications. Like two device, sender or receiver, or many receivers, one sender, or multiple devices are there. So those devices should be mutually authenticated because one device is sending and another is receiving. So there should be some mutual agreement between these two devices. Then only we will be able to establish the second one, that is the key. Otherwise, means we know that we have to do encryptions. For providing encryptions, we should have a key. So that key we can establish by mutual authentication only. We'll discuss those things better in detail. So these are the minimum requirement to ensure device security. That is, the first is the device should be authenticated, and then that network which those devices going to access, there should be some access control mechanisms that those devices should be allowed to access the network or not. That we have to ensure. And for that, what we need to do, one is mutual authentications, and the second is that key establishment. Then we are coming to communication security. The data is flying. That means when we are sending the data or another entity which is receiving the data, that in between data is on the network. So that time what we need to ensure? We need to ensure the confidentiality, integrity, as well as authentications and non-repudiations. I think these all are message security. So for confidentiality, integrity, we are coming to all the things, how we ensure that, and authentications, non-repudiations, that will come later in detail. So generally what happened? We have to do encryptions for that, first of all. So after that, our third thing is that user access. Who are the users who are going to access the data? Means data for access. That time what we need to do? That user should be authenticated first. After authentications, then we need to ensure that what type of data they should access, that access control mechanisms. Then fine-grained access, means a particular things. Here, one questions may come to our mind that what is the difference between authentication and access control? So generally, if we try to explain that, authentication means I can tell some things that I am I am so and so. But what is the proof that I am that person? If I am telling that I am Dr. Shantanu Chatterjee, but is there any proof that I am only that Shantanu Chatterjee or somebody else? So how to do that things? How to verify that things? For that, authentication is required. That means authentication should be given by some third party, where I have to register. Like when I join my organizations, that time they have given me one card, iCard or identity card. That means they have registered my data and then they have validated all the details, and after that they have issued a card by which I will be authorized, basically authenticated. So this is the user authentications. Like that, user should be authenticated, and before that, that user need to be registered. Then that particular user should have some access control. If after authentication also, that user should not access all the things. They should access a particular things, some of the applications. Some of the applications may not be useful for him or may not be required. So that access control mechanisms also should be there. Then another thing is that fine-grained access control. Means user is able to access a particular applications, but in that some files will be there where only read-write permissions is there, or read permissions is there, but not editing. No edit permission is given. So those type of things is fine-grained access control. So those things also we have to apply for these communications. So how to apply those things for at the top of the network level? So that is the main difficulty. So for wireless communications, we should check all these parameters. If any questions comes in mind, you can just ask the questions in between. There is no problem.
Hello.
Hello.
One of the things is that for authentication, there is a one type of identification, but not verify. It is identify that person is authenticate user. This means you have to first identify. There is a lots of parameter. That parameter should you compare. The thing is that when it is one-to-one mapping for each parameter. Now something it is so happen due to transmission, some noise is coming in the data. Noise is data. In that case, maybe 10% not match component wise, for example. If 95% matching, in that case, it will be, we can consider, because in wireless medium, noise is coming.
Correct. That is basically we have to put some threshold, like biometric
threshold.
Biometric-based authentications will come later in this presentation. So there also we need to check, we need to give some threshold. Like more than 70% is enough to take a decision. So like that we have to check. But the essentiality is that that person has to be registered first, and whatever the inputs parameters are there that he needs to give, those things should be validated by the third party. And third party, that other persons should believe that this third party, like in our case NIC, or who is issuing the certificate agency, those should be valid. That those partners should be valid first. So if those are valid partners, and if those authority is issuing some certificate for a particular entity, then based on some threshold, like they have collected the biometric of a person.
Okay, one of the input, this threshold is
sorry,
fixed or maybe vary situations to situations.
This
threshold is fixed or vary.
Based on applications, it is changing.
Dependent application, this threshold should be varied. Okay.
Yes.
Actually, in voice analysis, we have varying threshold we are using. For authentication, but natural language processing. Okay, same thing. Okay, thank you.
For any biometric case, that threshold should be there.
Okay, thank you. Okay.
So now, where the second security is essential, like the same things like for our entity security already we have discussed. For the endpoint devices, we have to make it secure. Then network security also discussed. Then another thing is coming as a cloud security. So cloud is multiple network, multiple devices are involved, and it measures how to protect the data during transmissions over a collection of interconnected network. It is not a single network. So that time we have to consider so many parameters. So that is a little bit challenging when it is coming to the wireless network security, because for like defense kind of applications, that's why we are not going for any public cloud. We should, if we want to adopt some cloud technology, then it should be on-premises private cloud. Because the third party means if that public cloud if we use, then there is a chance to chance of data leakage, because so many networks are involved, like internet. So many networks are involved. So for that case, that if the data is data security is major concern, then we should not adopt that kind of technology. So anyhow, that is based on the organization to organization, and now everybody is having their cloud security except defense. So everybody is using cloud also. So now I'm coming to the basic difference between identification, what I think Somin sir has identified. That identifications, then authentication, then authorization, then access control. These are the basic for the IoT communications or any wireless communications. Like these 4 steps we have to follow. Therefore, identification is, we know that identification is nothing more than claiming you are a particular person, you are somebody. Like I am Shantanu Chatterjee, you are something. So like that, claiming something. But authentication is how to prove that you are that person. That if I am claiming something that I am a scientist, then I have to prove it. I have to show some certificate, or I have to show some identity card or something. That is the authentication. Authorization specifies the party should be allowed or denied to access any particular applications or to particular any network. In case of network also, we have to authorize that for a particular device. This case is valid not for users also. This is valid for the end devices. For end devices also, we have to identify. Then we have to issue some certificate to the devices. And then those devices should be authorized, that they are authorized to access the network or they are not authorized to access that network. So that also you have to control. Then access control. In that network, maybe so many applications are there. So in that applications level also, we have to provide access control. After that, again that fine-grained access control, that whatever I have discussed just, that those things is coming after this access control. That is the granular level. So that these 4 steps we need to follow. Now, as this is for this is a FDP kind of things. So how to start basic research work in this domain? That I have done some things for you people. That if you want to do some research work in that security protocol for wireless network environment, then how you will start? Basically, generally, 2 open areas till now it is there, that remote authentication protocol. Another is access control protocol. So for remote authentication protocol, like multi-server authentication protocols are there, that is still open area. And there are some single server authentication protocols. So like single server authentications, crowdsourcing in IoT, in that area you can do some literature survey. And for multi-server, there are different enterprise class applications like ERP is there. Then so many other applications are also there. Then mobile cloud computing environment. In those areas, you can initiate your research. And for access control, that is fine-grained access control protocols. Until now, it is not that much research has already done. So basically, in that area also, you can do some things, and it may be useful for that telecare and medicine information system. So in those areas, literature survey can be done. So this I have just given some example where you can initiate your research. Now, to start anything, to design any protocol, what we need to consider? That is the threat model, because that is depends on the your particular organization's requirement. That what type of threat model we should adopt. If we want to consider a security for any system, then first we need to check that how much it is required. If the security is must and robust security we have to apply, then we should apply this kind of threat model. That is a well-known threat model is Dolvo-Yo threat model. Basically, these are some assumptions we are taking. That if we take that assumptions that our endpoint will never be compromised, then endpoint security will not bother. If we think that our users are genuine and they are coming and they are accessing the data in on-premises, no wide concept like bring your own device is not there, no cloud environment is there, no internet is there, then user is also secure. So you not have to think about the user security. Anything?
Phone pay ಮಾಡ್ಕೊಡ್ತೀನಿ. Phone pay.
Action ಏನಿದೆ ಸರ್?
ಯಾವ್ದ್ರಲ್ಲಿ
ಅದು additional.
ಅಡಿಷನ್ ಅಂತ ಹೇಳಿದಾರ? ನೀವು ಕೊಟೇಶನ್ ಅಲ್ಲೇ ಬರ್ದಿರ್ತೀರಲ್ವಾ ವಿತ್ ಟ್ಯಾಕ್ಸ್? ಅರ್ಥ ಆಗಿಲ್ಲ.
ನಾವು
ಹೌದು ಗೊತ್ತಾಯ್ತು.
Sorry to interrupt you, Hemlata ma'am. Hemlata ma'am, kindly please mute yourself.
So can I start?
Yes, sir. Yes, sir. Sorry, sir. One participant already.
No problem. I
muted.
thought that some question has come.
Amit sir, you have also right. You can mute anyone in the meeting.
Yes, sir. Momin sir, no issue, sir.
Okay.
Sir, kindly please continue, sir.
Okay, thank you. So that is that we have considered this generally for our research work. We have considered Dolvo-Yo, that is the popular threat model. It is a very powerful adversary model and widely accepted for any kind of research for the designing the security protocols. So here we have assumed that the communications, whatever the communications is we are doing, so those things are done over a insecure channel. Means the channel itself is not secure. So anything happen in that channel, so that we are considering. Then our endpoint also we are assuming that those are not generally trustworthy. So anything may happen. For some cases like sensor nodes or user terminals or endpoint devices, some cameras for IoT models. So those things are not at all trustworthy. So anything may happen to the endpoint devices that can be taken. Attacker can take it. They can do some analysis on that. So anything may happen to the endpoint devices. Like our own personal PC, sometimes our personal PC, we can take it as a secure. If we are not connecting with any network or we are not connecting with our USB devices, then no virus, no malware, nothing will come. Then we can take it as a secure endpoint device. But in this threat model, if we assume that we have to adopt this type of threat model, then we should consider that our endpoint devices are not at all secure. So like that. Then we are thinking that our attacker can eavesdrop all traffic. They can inject some packets. They can able to modify messages, or sometimes they can replay the old messages which is previously delivered. So that things also they can do. Even in our assumptions, we have taken that smart card also not secure. Those are also not tamper resistant. So that can be tampered, and any information stored in that smart card can be taken. So that also we have considered. And password also we have treated as a not secure, because that can be guessed or dictionary attack may happen. So like that, we have designed first that this will be our threat model. So we have to deploy or we have to design such kind of security protocols and mechanisms where all these attacks may happen, and these will be our test case for to ensure that security is provided or not. So this is very essential things before starting or designing any security protocols or any security mechanisms. Then what are the common security attacks in wireless communication that I try to discuss? That is generally, I think all of you are aware of that. Online guessing attacks, offline guessing attacks, then replay attacks, then man-in-middle attacks, user impersonation attacks, stolen verifier attack, known key and session key security, then stolen smart card attack, privileged insider attack, server spoofing attack, denial of service attack, ephemeral secret key leakage attack, all those things. Online guessing attacks, offline guessing attack is password guessing kind of thing. Replay attack is basically known as replaying the old message. Like I have sometimes before somebody asks me some questions from my side, the answer will be yes. So the attacker, what he will do, he will take my old yes message. And sometimes when again somebody asks me some questions and I have to give, I have give my answer is no. That time the attacker will drop that packet and instead of that no, he will just send the yes. So the entire meaning of the communication is changed. So that is known as replay attack. A valid old message, again it will be replayed to ensure attack. So that is the things. Then man in middle attack, that between two persons, one attacker will come and I'll explain these things in a detailed way in middle attack. Then you all this I'll discuss in a detailed way. So no need to go for this now. And then that major functionality requirements. What are the major functionality requirements? That also we have to ensure. That we have to, and after authentication, we have to establish session key, and it should be shared secured session key. Then you need to ensure user privacy. For some application, user privacy may not be required, but some applications, user privacy is must. So how we will provide? Using anonymity, that user should be anonymous, like that. Then the forward secrecy or known key secrecy, that any changes in keys that will follow the mechanisms, particular mechanisms, that is the forward secrecy. Then efficient login and authentication, efficient password change, and smart card revocation. Then efficiency with respect to performance overhead, that also you need to check. Because if you want to design a protocol for IoT environment or wireless sensors network, that time you need to consider the resource limitations of the sensor node or IoT devices. They are not having that much resource, they are not having that much memory, that much processing power. So if your security application is taking their battery overhead is too high, power requirement, as well as their applications, key generation mechanisms, encryption mechanisms is having heavily computational overhead is there, then it will not having that much resource, so it will not able to do the applications properly, do its own work. So it is very difficult to adopt that kind of security mechanisms for this kind of applications. So for this type of requirement, we have to check that performance. We should ensure that one second. Sorry for the interruptions. So the presentation is coming now.
Yes, sir.
So then that efficient login and authentications, that is also required. That performance overhead. So performance overhead for this type of resource limited devices is very much essential. Now I am coming to the mathematical preliminaries for designing those kind of protocols. So For entire things, we have to apply, we have to know that cryptography. We know there is symmetric key cryptography, then asymmetric key cryptography, then protocols. That is when we are designing the things. So symmetric key cryptography means there should be only one single key. So generally that overhead of the symmetric key cryptography is very less. So, but here the key is from the sender side and the receiver side, both sides should the same key is used. So whatever key we have used for encryptions, that same key will be used for the decryption. So there is two type of things like stream ciphers and block ciphers. So that is one more protocol is RC4. I think so. I will not go to the details. This is a general things. So just you should know the terms and that algorithms like AES, DES, and 3DS. These are popularly known as block ciphers. So these are the symmetric key cryptography where we should use a single key for encryptions. So mathematical overhead or applying symmetric key is very less. Means computational overhead is very less. But for asymmetric key cryptography, that is known as public key cryptography, which is based on two keys. One key will be used for the encryptions and other key will be used for decryption. Like there are two keys. One, every users or every devices is having their own private key as well as one public key. Public key is given to other parties, means all the others except that particular person. And private key should be belongs to that person only. So whatever encryptions you will do by private key, that will be decrypted by the public key, like that. So there are so many mechanisms like using integer factorizations. RSA algorithm is there, that is a public key cryptography. Then LGML is there, that is based on that DLP problem, discrete logarithm problem, and another discrete logarithm problem over this is discrete logarithm problem over polynomial. So that is LGML, and discrete logarithm problem over elliptic curve, that is elliptic curve cryptography is there. Then another thing is that like Chebyshev protocols, that is also based on that asymmetric key cryptography. So many protocols and so many asymmetric key cryptography algorithms are there till now. So using all these things, you have to design the protocols. Protocols means security protocols means it should provide authentication, it should provide authorization, it should provide access control, as well as basic encryptions also. So all these things should be provided by the protocols. So like that way, we have to design. So like some important statements we want to discuss. That is, the public key cryptography has higher computational overhead as they require larger key size. And public key cryptography are extremely helpful in encryption, and digital signature without public key is not possible. Also, we should use Diffie-Hellman key exchange. That is, using public key cryptography, we should generate some symmetry. So that how to generate that things that we will discuss. But as it is a VC, it is very difficult to explain the things. In board, it will be very easy to explain. Anyhow, and for message encryptions, like we should prefer symmetric key encryptions because like AES, because generally for any encryption mechanism, if we use public key, then it already I have discussed that it will take high computational overhead. So we should avoid public key cryptography only for encryptions. Only for encryption, we should use symmetric key. And then for like so for message authentications, we need to check the integrity of the message. We should apply some hash or XOR operations, which are having negligible computational overhead. So we can use any number of hashing or XOR operations to design our protocol. So for our case, we have used one hash function like SHA-1 or SHA-2. Then biohash techniques and fuzzy extractor we have used. Then symmetric key encryptions, generally for smaller applications, we should use AES 128-bit, because another things we need to keep in our mind that security is nothing that much essential if your data is old, because that is also depends on application to applications, because always there the value of the data is when it is real life or when it is reset. That time the value of data is there. So that time if attacker is able to attack it and get it, then only it will get some value. Otherwise it is not there. So using a huge key, large size of key, you can secure it more, but it may not be useful that much, because 120-bit is also sufficient. And without knowing the key, if they are able to know the key, then they can break it at any time. But without knowing the key, 128-bit means 2 to the power 128 computations is very tough. So that's why almost if it is required, then you can increase the key size also. That 256-bit also you can do, 5 or 12-bit also you can do, based on your applications. Then discrete logarithm problem we are using. So for that, generally we are using elliptic curve ECDLP, elliptic curve discrete logarithm problem. And nowadays, as a lightweight authentications, we can use chaotic map based discrete logarithm algorithm. So that is Chebyshev polynomial algorithm is there for that. And for key exchange, we should use Diffie element key exchange. There are two types of generally key exchange algorithm: elliptic curve and chaotic based map. And for kind of fine-grained access control, if you want to provide, then attribute-based encryptions and bilinear pairing is required. I will not go to the details, maybe multi-dimensional FDP. So many persons may not be interested for this kind of things. So I'll not go to that. I just tell that advantage of ECC over RSA. RSA is a very popular, well-known algorithm. So everybody is knowing that RSA is good. RSA is good enough, but compared to RSA, ECC is much better. Like if you check that same security level, RSA is required 1024 bit, but for elliptic curve is required only 160 bit, and for AES it is 80 bit is enough. So like that way is comparable. And for execution time, if you check, then RSA is taking very high value. I'm not considering here as it is having a very high value. But elliptic curve compared to elliptic curve multiplications, Chebyshev is also taking so many little time. Just 1/3 only around. So we should use Chebyshev map if you want to reduce the computational overhead.
Hello.
Hello.
Chebyshev actually that Chebyshev's inequality what we are using in the probability theory for central convergency. From there we have collecting the data at 21.02. Chebyshev's map operation is Chebyshev's inequality.
Yes. From there also, or in our lab also we have performed that.
For lab we have to develop that analytical model already getting from the probability theory.
Yes, correct.
Expectation. One of the things is about the crypto system, then security level top line, the 80 is there. And RSA 1024 is 1 MB. The 80, 128 bit, how integer
They are giving the same level of security. Means,
same level.
Means if you want to break that security with your own data analysis, so that time, what time it will take to break the security?
Okay.
RSA is taking that time with 1024 RSA key. What time it will take? The same time it will take with the 80-bit AES.
Same time.
So that's why having the similar security infrastructure they are providing, where it is required 1024 bit for RSA, but for AES or 3DS it is only 80 bit is required.
Okay. So one of the important one-way hash function, the value is 0.5 means half. The one-way hashing function, just we have encrypt the data. Hash one-way means we have encrypt and decrypt.
No, it is not encrypted.
Encrypt. And
No,
that time,
it has one kind of, it is a one-door function.
one way, that one way.
So
Encryption.
we are just taking the message digest.
Oh,
So it will ensure the integrity. Means if I am sending a data and I am sending the hash of the data also.
okay. Now, take an example. For example, software radio. These people are working with that area, I suppose, for coordinating the number of aeroplane or that fighter jet. That we are using the encrypted data when they are communicating, and there's a frequency hopping. In that case, what is happening? When you have encrypted data and frequencies hopping channel wise, that is this type of algorithm is working.
It will work. Basically, hash is required to check the integrity of the data. Means whatever you are sending, you can encrypt it. So it is secure. But after decrypting, you are getting the original message or not. Means after decryptions, like I am sending Apple. Now Apple I am encrypting as some code by like XXX. So you are receiving some XXX by when you are decrypting it, but it is at the time of decryptions, it is coming as orange. That means data is changed. It is encrypted properly, and you are getting the message. After decryptions also, you are getting some message. But is it changed in between or not? How to determine that? So for Apple, if you make a hash value, so that means a hash value will be 1 1. So it will be only for Apple. It is applicable only for Apple, 1 1. But for Orange, it will be maybe 1 2 or 1 3 or like anything. But it should not be 1 1. So when you are taking the hash of that message also, and after decrypting, again we have to compute the hash of that received message, which you have decrypted just, and then you can check if it is differ. That means message has changed. Somebody, some attacker has changed the message. So that means integrity is not there. So to ensure the integrity of the message, hash is required.
Okay, for example, sometimes it is so happening that the data, whatever I have decrypted, with that some remainder is appended. In that case, what is happening?
That time hash will be changed. So
Hash will be totally changed.
They will be able to detect that things.
They will be totally rejected. Now, sometimes I have received on Apple, which shape is different. I to understand. In that case, what?
That also that person will be able to take the decision. That means hash is not matching.
But writing
also, it will not make it same thing.
So for writing the code for these types of algorithm, one-way hashing or symmetric, we people said using a C or or what types of algorithm?
Now that SHA algorithm is available in any language, you can just call the function.
Now, if I have to modify lots of things, then C will be better, na?
And obviously C.
Obviously, so all the people are using C. Python is lots of header function. Is that header function sometimes we cannot modify within main. Better to for student perspective or research, sir. Better consider C.
Correct.
Okay, thank you.
So other things are like elliptical cryptography, then bilinear pairing. Bilinear pairing basically used for attribute-based encryptions. So that I'm not covering that. And then Chebyshev polynomial already I've discussed. This is basically on the semi-group property of Chebyshev polynomial, and chaotic map-based discrete logarithm problem. So if a person interested in this type of research, they can just go through this. So they can do. And then biohashing is also there. That is useful for three-factor authentication. What it was discussed. That some threshold we have to consider here, because some noise factor may be there. And one-way cryptographic hash functions. That is the minimum computational overhead is there. So if you able to design a protocol only using hash or XOR, then it will be the most efficient one. But you have to check that you are ensuring all the prerequisite in that case. So I'm not going to the mathematical details of those things. It is sometimes boring, and without board it is very difficult to explain. So I am not going. Hash is, I just explain the hash things. Yeah, here, like if you want to take a hash of x, then y equal to a hash of hx. Then if y is not equal to x, then you cannot able equal to hash of x. It is never possible. Even you cannot able to find out any pair x or y where x not equal to x, but h of x equal to h of y. That is also not possible. So that is known as strong collision resistant property. The previous one is known as weak collision resistant property. That means there should not be two values for those two values. If those two values are not equal, then their hash should not be equal. It is never be equal. So that way it is known as one-way hash function, and it is used for ensuring the integrity of the message. So in between, if one bit of the message is changed, then its hash also will change. So this is the thing. So now that I'm just coming to the biometric and fuzzy extractor. So generally biometric keys for authentications we should use it now, because password we cannot it may not be trustworthy that much. And biometric keys are difficult to copy, or we cannot share it also. So it is with you, your biometric. It should be with you only. We cannot lost it also. And fuzzy extractor we designed like somehow we have to store our biometric. So if you store your biometric information in some smart card or in some device or in some server, then there is a chance that it can be taken. So that also we have to ensure. And it is more secure than passwords, and also it is having the probable security. And till now, no one can find a successful attack on them. That that encourages us to use this kind of biometric and fuzzy extractor, biometric and fuzzy extractor. So here I'm describing the working principle. Listen carefully. Like one function is there, like I am taking the fingerprint as a biometric. It may be anything like your iris scan or any other like your voice information, anything, any biometric based information. So when we are taking the information, at that time we are applying some algorithm. That is, here I am explaining it as a generation algorithm. So using generation algorithm, will give that biometric information as an input to this program, to this generation algorithm. Then the output will be two things. One is alpha, another is beta. Alpha is the unique string for the biometric, and beta is some biometric data points that is generic, that is may not be unique. Those are general data points. Then what we'll do, we'll store the biometric data points into the smart card, any smart card or any server or any endpoint devices which is secure, where we have to store the biometric informations. So those are the general biometric informations we are storing, but unique is this alpha, which we are not storing anywhere. So now if the card is taken or card is stolen or card is hacked by someone, then also they will get some data points, but not my unique feature, my unique biometric features, no attacker will get. So like that. But that means how then it will be authorized, how it will be authenticated, because this smart card is not having all the information. So for that, what we'll do, at the time of authentications, you have to insert the smart card, and you have to again you have to give the same biometric, whatever biometric you are having. So from smart card, our program will take the beta, and that is the general biometric data points, and from this biometric informations will take beta as input as well as our biometric as input to this reproduction functions. And These reproduction functions will generate alpha again, alpha dash. May not be same like alpha, but it is alpha dash with this reproduction function. And then we have to compare this alpha with alpha dash. If it is matched, like there should be some threshold. If it is matched within the threshold limit, then we will accept it as a authorized person. So like that way, we have to do where there is no chance for the biometric information. It should not be taken, or it should not be hacked, or it should not be compromised. It is with you only, and the smart card, whatever you are having as external device or external card, that if it is lost also, you lost it or it can be stolen, then also no problem is there. Your data is not in that. So your data is secure and it will be properly authorized. So that is known as the biometric fuzzy extract. I think it is explained, means you people are getting that things. If any questions you can ask. So I'm going to the next topic. Now for the security verification and simulations. For doing research and publishing papers, you have to propose some things. Then after proposal, after the proposed algorithm, you have to verify it. And for verifications, you have to do some formal or informal analysis. For security verifications, there is this type of things. One is formal approach, one is informal approach. So formal approach, that is simulations for security verifications. For security verification simulations, you can use two tools are there. Well-known tool. One is ProVerif. We have used 1.93 version, but now I think some other versions are also available. It's more than 2 now. And another one is Avispa, that automated validations of internet security protocol analysis. So this Avispa tool is also very useful for that. And formal security verification, you can use band logic, real random oracle model, and random model you can use. And for informal security analysis, informally you have to show that your protocols, proposed protocol, is secure against the all well-known attacks. So this is required to publish paper in security area. So you analyze the security protocol schemes using those methods. So I am not going to the details of the random oracle model. This is a random oracle model where so many things are there. I will not go to the details. This is the Whisper tools. So here you have to write the Whisper code in HLPCL language, that high level protocol specification language. And there is a intermediate format, IF format, it will transfer. And then using this on-fly model checker, one of the simulation tool, and control based attack searcher, ATAC. So here it will search for the attacks. And in on-fly model checker, it will do all type of attacks on the fly. And if any attack is there, it will say that that this is not secure. Attack may happen. Here also it will simulate like with all the known inputs. It will first simulate, and as an attacker, as a genuine attacker, insider attack, it will simulate that things. Then SAT-based model checker, that is also same kind of insider attack, and then pure automata-based protocol analyzer, where step by step they will verify. One kind of white box testing type of security analysis. So with that, we are getting that output format where it is showing that it is not having any attack, or if it is having any attack, then what type of attack, how it is happening, those it will be given. So this is a very useful language to check our designed proposed security protocols. So this is the descriptions. I'll not go to the details. is the same things. And another tool is that ProVerif. ProVerif tool is based on the applied by calculus, which formally models the systems where you can just verify the reachability, traceability, and the session key. We have to establish the session key for authentications. That session key to check. Then channels, constants, what are the constant used, functions used, those things, and then unbounded message sessions and bounded message sessions you can check. So that also it is a simulation tool. So using that also you can verify. Now I'm coming to the application of IoT. These are the general things where you can start your research. Now IoT is a well-known topic for home security, for transport, for community, for national defense, for industries, policymakers, everything they can use. So many sensors are available, so many data are there. So you have to do analysis. Even the researchers who are interested for AI ML, they are also interested on those data. But if the data is not proper, if the security is not mentioned properly, maintained properly, then you will not get the real information, real image. So we have to ensure the security first. So for IoT security, these are the layer wise I have defined, that application layer wise security, then transport layer, then perception layer. So for IoT applications, if you check that application support layer, it is basically you have to do for cloud computing security, middleware technology, and cloud platform security. Then for transport layer, it is coming as a LAN, because you have to do some local area network, and then code network, then access network. LAN, code network, then access network. For internet, you have to provide the LAN, then you have to provide the code network, that is internet security. Then that Wi-Fi, ad hoc security, GPRS security, for all those things, access network security. Then after that, perception network is coming. That RFID security, WSN security, RSN security. This is the ground level where sensors are involved. There you have to provide this type of security. So application wise, you have to make secure your applications. Then transportation layer wise, you have to make secure your internet, your LAN, and then whatever the access network, how you are accessing the sensors, how you are accessing the endpoint, that is coming. Then the perception layer. Among the sensors, because a particular camera or a particular sensors collect some data, but it is taking the data from other sensors also. So there are so many things. We have to make a cluster kind of things where we are able to take the data, and those data will be further processed, and then it will give the information. So in that case, among those sensors, we have to establish a network. That is generally WSN or RFID or RSN. So those things we have to check. So for audit also, like OSI layer, we have make 7 layer of security. That is ISI audit, IoT audit. We have to do. The physical sensors and controllers are there. That is the layer 1. So that is the things of IoT. Things in I of T, IoT. So that is the physical sensors and controllers. Then the gateway or edge computing is coming, where we are doing the data filtering, we are doing the analysis, then communication interface protocols and also security protocols we are applying on that. Then we are giving network connectivity, internet access. We have to give the network access there. That also we initiate. Then data abstractions, like security, aggregations, filtering, all those things we have to do. Aggregation of the data is must. Then we are storing the data in servers. Storage is coming. Then what are the software used for that? Then what are the redundancy? How data backup we are taking? All those things are coming. Then the applications. We are applying some analytics, reporting, control. Then business applications are coming. Then how we can optimize the performance, particularly 3P, purpose, people, and process, based on our requirement. We have to. So these are the 7 layers for IoT audit. Now I am coming to the attacks of IoT-less applications or sensor-less applications. So this is a model, like at the ground, the sensing and local processing element are there. Those are the endpoint. They are collecting the data, like your cameras, like your sensors in the field. They are collecting the data and they are sensing informations they have to send. How they will send it? It is in a hop by hop manner. They will connect to the gateway node or base stations. So they will pass those messages to the gateway node or the base stations. Then generally base stations or gateway node is communicating with the internet. It is connected to the internet. From the internet, user like our using our cell phone or using our laptop, we are accessing from the internet those data. So basically those data like our GPS, the sensor is there. That is passing to the gateway node, the station. The station is supplying those data to the internet. And from internet, we are accessing the data. So these are the user terminal. And based on the like a particular example of the things you can check in your home, you put some cameras. So what it will do? A camera will take the data, it will take the snaps, and those data will pass to the gateway node. If your home 3 or 4 cameras are there, then those things should pass the gateway node or the station, that is the router, that wireless access point, and from there it is connected to internet. From internet, you are getting the data. Some user terminal are there. So now, from user terminal, you will give some message after getting the data, that to shut down the light, or to switch on the fan, or switch on the AC, or switch off the AC. So that command you will give again to the internet. So it will again pass the information to the internet, and from the internet it will go to your home with a command and control unit to switch off or switch on anything, any mechanical device. So this is the command and control unit. So like that, this IoT-based application is working. Now, what are the threats? Attack may happen to any sensors directly. If it is connected directly with internet, then some IPs are there. So using that IP can be spoofed, or any attack may happen. And in agricultural land or defense, if we put that things, then those areas are unattended. So any person, any attacker can take it, give some rock sensing information, rock sensing element, and which will give you wrong data. So attack may happen on those endpoint devices. Then when you are passing the information to gateway, that time, if you are not mutually authenticated these two, and it is not in a encrypted way, it's coming the data, then attack may happen and data can be taken away, and rogue data can be given to the base stations. So you will get a wrong data. Then I think that we assume that gateway node or base stations is physically secure, so nobody can do attack. It's okay. But when you are sending the data to the internet, again it is wireless communication is happening. So here also attack may happen. Then from internet, when you are accessing the data, that time also attack may happen. Then your user terminal, your smartphone, your laptop can be hacked, can be stolen. So attack may happen on that also, because that is also a device. Then again you are sending the command and control data, the command and control unit. That time also attack may happen. So this is basically, if you check, everywhere basically the attack may happen. So if you need to secure your IoT-based applications, so many security concerns you have to check. That attack may happen this, so you have to secure this. Then attack may happen in media, you have to secure it. Attack may happen in this media, you have to secure it. Then user terminal. So many things are there. So for IoT security, if you go for taxonomy of IoT security threats, then we are having device security, then communications or network security. So for device security, there is hardware or software security is there, because devices means a device should have that is the hardware, and that hardware, on top of the hardware, some softwares are there. So you have to ensure the software security as well as hardware security. And for network security, you need to provide authentication, access control, and for encryption kind of things, you have to generate the key. So hardware security. If you check that in India, hardware we are not developing. Sometimes we are designing, but we are giving it for fabrications. We have offshore it. We have to offshore it because we are not having the facility. So the problem is there. So specification, design, fab can be taken, can be hacked, but not that much. Security may be there, but it is also doing. But third party is responsible for doing all these things. We are using tool, machines, that manpower, or everything on third party basis. After designing, again we have to give it to fabrications. For mask and masking and fabrications, we have to offshore. That means it's going to some outside India. So that time anything may happen. Anything. If like in your hardware, you know that lakhs gates may be there, lakhs of crores of gates may be there. So in a particular gate, you just add a NAND gate. Then what will do? What it will do? And with a counter value. That after 1,000 or 2,000 cycles or 1 lakh cycles, that NAND gate will be operational. So what will do? When you are testing at that time, no problem is there because up to 1,000 cycles or up to lakh cycles, no problem will be there. Its counter value is there. That limit is given. So, so that time it is tested, it is operational, everything is okay. You have checked, and you cannot able to find out one particular NAND gate. It's very difficult to find out. But after 1,000 cycles or 10,000 cycles, means after your warranty period, that NAND gate will be operational. So it will negate. Suddenly you will get an experience that your device is not working. That means a hardware trojan or hardware box is there. Intentionally it is given at the time of fabrications. So that after certain cycle of operations, it will start its own work. So that a device will not work. So we cannot believe on that. But unfortunately, we have to use it because we are not having that much fabrication unit in India. So that is the hardware related problem. Then these are hardware trojans. Software, we know that so many valuable money. I will not go to the details. You know that all the software, all the ways there need to be patched, need to be updated regular wise. Otherwise, so many vulnerabilities are there. Threat, attackers, all those things. I will not go to the details. So these are the typical software vulnerabilities like buffer overflow, input validations, code defect, design defect, and crypto related. So crypto related is very less. The main things are this: buffer overflow, input validations. Buffer overflow is the maximum, then input validation, then code defect. All those things are there. So that time you have to fix it. This security bugs found in Microsoft on 2002 is a very old things. That's why they are releasing patch and you have to update it. And for that, you have to have an agreement with that. License agreement you should have. Otherwise, you will not get the patches. Now, for IoT kind of things, what are the problem? If we apply directly available networks security techniques, directly we know that so many network security protocols are available. Why we will not apply that? But we will not able to apply on IoT or this type of wireless sensor network kind of things because of this code, that sensing unit. It is a large number of sensor nodes are densely deployed. So it is very difficult to identify the nodes after deployment. It may be rocket fired or may be deployed in an unplanned manner. So it is very difficult to find out all those sensors after deployment. And it involves in sensing, communication, data processing. And then base stations. It is secure and resource rich. So we are not having any problem with these base stations. But user unit, again, it is vulnerable. what we have discussed in the command and control unit. Basically, the problem is the resource constraints. That sensor node is having limited energy, limited computations, and limited communications, and it is deployed in unattended deployment area. Like lack of knowledge about the deployment configurations, there is no planned topology. Network topology we know. If we know the network topology, then only we can resolve the network issues. But if it is not a fixed topology, it is not following any fixed topology, then how you can ensure network management? Very difficult. Then there is a chance of node capture. Node can be captured and rogue node can be deployed. What means sensors? And it is close to interact physical environment. Sorry, one second. Hello. मैं थोड़ा बिजी हूँ बिजी बाद में and then wireless medium. So that wireless medium we know that message interception is possible, man in middle attack, DOS attack is also possible. And these are the functionality requirement. The dynamically node may be added. Scalability of network is there, high scalable. Mutual authentication is the required things. Data availability is required all the time. And it should have a minimum computational and communicational overhead. Storage requirement also very minimum. We cannot store so many data. So this is the general authentications. I will not go to the details. Already I discussed things. So like this is the classical methods of hierarchical wireless sensor, where sensor nodes, these are the sensor nodes, these are the cluster heads, and this is the base stations. So base stations is okay. Sensor node, how they are communicating? They are communicating with hop by hop manner. If this sensors is collecting some data, then it will pass the data to the nearest sensor node, which again pass to the cluster head. Then cluster head is passing in next cluster head, which is near to the base station, and then it is passing to the base stations like that. It is coming. So this is the distributed wireless sensor network where no concept of cluster head. In a hop by hop manner, the data is coming to the base stations. So it is very easy to deploy, but very difficult to manage. So in military applications, environmental monitoring, health monitoring, industry applications, classroom monitoring, you can use this. So now I am just going to give a example of our defense environment where we are planning. So this is a border security kind, surveillance kind of things, where we put some sensors. So these sensors are having their own communications range, and it will establish a network between them. So this is then it will become a wireless sensor network. So now it's covering the entire range like this way. So whenever a particular enemy tank will come, so it can be detected. And whenever it is detected, in a hop by hop manner, it will send the informations to the base stations. And then from base stations, the command and control unit will take the action, and missiles then be launched and it can be destroyed easily. So like that. So then another application is wireless body array network. Like here in a person's body, we have to put some wearable sensors like ECG monitoring, motion sensors, everything. And it is connected to the personal server, and through GPS internet it can be monitored easily by the medical team. So these are the typical device for WBN. So this is the standard for 802.15, because here we have to take the battery power and packet error rate should be minimum like that. So many considerations are there, and transmitting capability should be below than 0.1 milliwatts. So these are the things. So here I'll just give an example. Like this type of sensors can be used for a particular person, like IMOD2, LSB2, IMOD2 as a cluster head can use it. So these are the cluster head symbols, and use it. So like a person body, the network will form like this. And this is the iMode 2, which is react as a cluster head. It will be able to communicate with the base stations. So these are the example of the name of the sensors. Now there are access points and base stations. So base stations are connected to the database server. Now this person is not near to the base station. So what it will do? It will send the data to the other persons which is near to the base stations. Like here also same things. So then these two will communicate with the base stations. For other data also they are only sending. Then there is a person, medical assistant is sitting, who can access the server based on the server. So like that it is happening. Or directly they can access the cluster head also. So it is close to the network. So this is the difference between WBN and WSN. I will not go to the details. So there are so many attacks that already I told that that attack of interceptions, message can be intercepted, and attacker can take the decisions by intercepting the message. These are known as passive attacks because here they are doing the traffic analysis. They are not doing any active things. But active attack is interruptions, because when they have interrupted this link, so they are only getting the data. So this receiver is not able to receive the data. So that is known as active attack. And again, when they are fabricating this and sending this message to the receiver, some different message, then it is known as the fabrication attack. So replay attack is like that, that this is the sender, this is the receiver. So the sender is sending the message, attacker is taking it, and after some times attacker sending the message to the receiver. Same old message without any fabrication or without any modification. So, but we know if the answer is yes for some situations, and that answer yes is taken, and after some situation arise where answer should be no, and then the yes will be replayed, then what will happen? So the same things may happen for this kind of scenario. So this is the replay attack. For stopping the replay attack, we have to use timestamp sequence number like that. But the difficulty in IoT or wireless sensors network, the timestamp may not be useful because it is not synchronized. Time being is not synchronized. So that is the problem is there. So then man in middle attack. So here the message is taken, discard the original message, and then attacker will modify some message, and then that message is sending to the receiver. That is known as the man in middle attack. And at the time of reply also, again, when it will receive the message, it will send again a message. That message also it will discard, and it will modify it and send it again to the sender. So like that, they can establish the key also, session key. So this protocol I will not discuss now. I think time is already limited. So I'll try to finish it. So DOS attack is, we know that basically we need to busy some things like that, that particular persons or systems cannot operate the network, and that way it is we are doing that attack. So like the TCP is flood attack, that SYN flood attack. Like we are sending a SYN packet, generally when we are establishing a TCP connections, that time we are sending the message, SYN message, and then acknowledgement message we are receiving. SYN acknowledgement message we are receiving by the receiver. It is receiver sending that, and sender is receiving, and then sender is sending the acknowledgement message. Like that way, TCP three-way handshaking is happening. But if I am sending the SYN packet, and whatever you are sending the acknowledgement, it is not coming. So what it will do? It is the hub TCP connections. So handshake will not happen. So its buffer, this TCP server's buffer will be full, and after some times, if some genuine SYN request will come, then also it will not able to access that. So that availability will hamper, and that way the attacker will take the advantage. So that you know that 2017, I think that Mirai botnet attack was happened. Here, so many, like you know that webcams are there. So people are putting the webcams and they are using the IP. So what they are doing, they have scanned all the vulnerable IoT devices, and the IP addresses of the vulnerable devices they are sending to the loaders. So what loaders will do? The loaders will log into the device directly by attacking, because those are the simple webcams. Only they are having IP. They are not having any security mechanism. So it is very easy to log on to those devices and downloaded some botnet malware in that. And then those devices will act like a bot, and they will start the victim server. They will send the message to the victim server. So like crores message are coming, and the victim server is overwhelmed. They will not able to answer it, and that DOS attack, denial of service attack will happen. So like that they have done. So if you are ensuring any kind of this type of IoT devices or anything, then you have to ensure the security of the endpoint. If it is a webcam, then also webcam should be secure enough that nobody can hack it, or nobody can able to install any malware on that. So that also we need to ensure. So for denial of service attack, we have to do the mutual authentications, and proper authentications login is also required for different type of IoT devices. I'm not going to the details. Already time, I think it is over. So password guessing attack is also possible. Offline guessing. Anonymity also will have to provide that user should be anonymous. I'm not going to the details of that. So these are some of the protocols which we have published in some different journals. So I will not go to the details of the fine-grained. Just I'll tell you that how we are giving the fine-grained access control. Here, this is the best of AND or graph. So like these are the persons which can access a particular things. So if it is this clear, then if it is infection is not true, then it is reaching to this. Then after that, if it is pulse, then pulse rate will be considered. Then if it is doctor, this 2 out of 3, it is true. Then using AND or graph, the user access structure is accepted. So for this kind of fine-grained access control, where everybody is authorized, doctor, staff, admin, patient party, everybody is authorized. Then also they should not access a particular information for a particular patient until and unless they are having this type of access structure. This is by this way we can ensure the fine-grained access control. So like that is given. So that is our some paper on fine-grained access control. So I will not go to the details of those kind of things. I will not go to the details. So I think for future research directions, we have to propose some lightweight mutual authentication between sensing unit and server. Then there is a research scope for fine-grained access control for real-time data directly to the from the sensing unit to the destination. And access control applications for specific IoT environment like VANET, vehicular ad hoc network. In that also the research scope is there. And real-life implementation of the proposed scheme. That is the really tough one, but we should ensure that. So that is the future scope of research work. So thank you. I think I have completed in time. Maybe 3-4 minutes delay.
Santanu, please send the PPT to me.
Yes, I'll share. I'll send it through mail.
Okay. Thank you for your wonderful presentations.
Namaste, ma'am.
Thank you, sir. I request the participants, if they have any queries or questions, they can ask.
I have questions. Santanu, for implementing these simulations, what types of machine configurations is required? In normal PC, we can implement or extra RAM?
No, for IoT kind of things or for wireless sensor network kind of things, normal PC or laptop is enough.
Enough.
Enough. That is enough. Because those are resource limited devices, so it is not. For research purpose, it is not required. For real life implementation purpose, that is based on applications you have to.
We have to GPU based machine is required.
Correct.
For a secure socket layer, SSL is a for IoT implementation. There are lots of vulnerability. Every time channel is open, port is open. Every layer we have to secure, data secure and network secure, port secure. Then how data will be transferred? If you secure lots many things, the data will be passing very slow.
Now that we need to, because that's why that whatever the available security protocols are there, like SSL or other things, so those cannot be directly adopted for this kind of environment. So special protocols we have to design, and only those protocols will work, because those standard protocols are having too many overhead.
Okay, in this area, I think if you are working with that, can you share some documents? Because we are lagging data, but security level data is very, and I know very well from DRDO side we cannot get any data.
Research papers, but data also we are not able to give.
Okay, but generating data, lots of things I think about student project or collaborative work. Okay, I will talk to you regarding this. Please send the PPT. I'll go through the PPT. Very interesting. Very interesting. Traffic model, and there are lots of things are remaining.
I am also not able to cover all the things.
Oh, lots of things I understand. Right? Because 1 day, 2 days is time. Okay, thank you, sir.
Okay. Can I leave? I think.
Thank you, sir, for sharing your valuable knowledge with us. The session was highly insightful and informative. Thank you again.
Oh, thank you.
Navasri ma'am,
Yes, sir.
second speaker also joined, Mohit sir, and already joined.
Okay, sir. We can start off with the second session for the day.
Yes, Jaita ma'am, we can continue now for the second session.
Sir, yes, sir. I think Amit sir has joined already.
Amit Bhattacharya already joined.
Yes. I have joined.
Good afternoon, sir.
Good afternoon. Now it's lunch time.
We cannot see you.
Oh, okay.
Yes, sir.
Okay. Now I'm visible. Anyway.
Navoshni ma'am?
Yes, ma'am. Okay. It's my privilege to formally introduce our second speaker of day 2 of this FDP program, Dr. Amit Bhattacharya, sir. Dr. Amit Bhattacharya received the PhD degree chemistry from the University of Calcutta. During his doctoral studies, he was associated with the Saha Institute of Nuclear Physics, Calcutta. His research orientation is mainly based on water purification and polymeric membranes. He was the recipient of the India Institute Fellowship Program from the University of Birmingham, UK. He was also the recipient of Rashtriya Gaurav Award, Bharat Vikas Award, and Best Senior Researcher Award from different organizations. He is associated with the water-related activities as recognized as the Institute's thrust area. He has compiled the thematic publication, CSIR Strives Towards Safe Water for All, for CSIR Platinum Jubilee celebration of CSIR activities in terms of water. He took the initiative in societal mission actions to install de-arsenification plants in the country's arsenic area and part of the working team. He was the coordinator of supplying water through reverse osmosis mobile van CSMCRI in the Ayla cyclonic storm 2009 affected area Sundarban in West Bengal and stayed there for approximately 15 days. The research contribution of Dr. Amit Bhattacharya has been marked by the survey of prestigious Stanford University, USA. He has figured among the top 2% scientists in the global list in polymers area for the consecutive 3 years from 2020 to 2022. His research recognition is built upon from national and international funding sources, IFS Sweden, BRNSDAE India, DBT India, BST India, GUJ, apart from CSIR India. He has the credibility of publishing 109 papers, articles, patents, book chapters, author of popular science book in Bengali language, conference papers of 67, editor of one book of Wiley Blackwell publications. His research citation has crossed the 5,000 mark. He was the host of Professor Hassan Hefni from Egypt under the RTF DCS program of DST India. We welcome you, sir. I request you to kindly share your valuable knowledge with us.
Thank you. First of all, I want to share the screen. Now I think it is visible, no?
Yes,
Yes,
sir.
sir, is it visible?
Anyway, thanks for the introduction. Here I am presenting different type of manuscript, a different type of topic that is related to scientific manuscript writing. And hopefully we are accustomed with this, but how to write the particular scientific manuscript better, that I am suggesting with my experience and as well as literature survey. This is related to colors in the rain. That is, we can compare our research is colorful and we are fond of different colors or different orientations of research. That umbrella is showing the different colors or different flavors of this thing. And this first we will start on why we do research or what is our particular, why we build up our scientific approach. And most of the particular present slides are related to scientific writing. It is descriptive. Just if you see something odd, you can stop me. Anyway, a scientific approach is essential as drug, medicine, water purification, artificial intelligence advances rapidly. So the need for a critical evaluation of new developments becomes more urgent, as well as writing skill, what is our topic today. What authors will investigate, why it is important, and how authors will do the research, and how authors will present to
Amit sir, sir, sorry to interrupt, sir. Your slides are not moving.
No, not yet. I have stopped sharing. It is moving now.
No, sir, still now not moving, sir.
Sir, please go refresh.
Sir,
Press the button. Okay.
yes, sir, now it is moving, sir.
Now it is moving.
Sir, also please one request, sir, make it in slideshow mode.
Slideshow mode, I am just giving this slideshow mode. Now it is moving.
Sir, it is not slideshow mode, sir.
It is slideshow mode. It is slideshow mode.
Press F5, press F5.
Amit sir,
Yeah.
Yes, sir.
Amit sir,
Yes,
Yeah.
sir.
have you opened your presentation? Sir, your presentation is open.
Yeah.
Just click on share screen button and select your presentation. Don't share your screen, just select your presentation, sir. Once you click share screen button, one window will appear. In that window, just select your presentation, sir. You can double click on it.
Double click on it.
So click on share screen button, one window will appear. And in that window, your presentation was there, and just double click on it.
It is not coming.
If you open many files in your system, then you need to scroll down.
No other files are there. Window. Share. Now it's coming.
Yes, sir, it's coming.
Now slideshow I can operate, no?
No, sir. It's still a normal view, sir. I can see there's no slideshow view.
Now I am doing. Okay. Now it's okay, no?
Sir, can you move your slide? You are on your first slide, I think.
Now it is moving.
No, sir, still not moving. Yes, now it's moving. Now you're on second slide. You
Now
can
second
continue,
slide.
sir. You can continue this way. You can move your slide this way.
Okay, no problem.
Yes.
Anyway, sorry for the interruptions. And this is author's intention to do the research. And why research? This is a critical scientific attitude to develop the critical scientific attitude, chance to study a subject depth, development of special interests and skills, understanding the attitude of others, whether in routine or research laboratories. Better convincing ability to readers or listeners, obtaining a status. Now it is visible, no? Hello, it's visible.
Yes, sir, it is visible.
Anyway, the particular shape of the scientific research writing is this is symmetrical, and this particular narrows down towards the central report section and widens after it. This central part is methodology and results. That means what you did and what you found. And this is get in through opening sentence, through introduction, and get out with concluding remarks. It is symmetrical. Of course, it is symmetrical. Introduction, many things you need to do are already done. Discussion or conclusion in reverse order. That means you are, whatever you know, you have to present that particular things. This represents the way information is ordered in the introduction and the discussion and conclusion. In the introduction, you start out by being fairly general and gradually narrow your focus, whereas the opposite is true in the discussion and conclusion. Anyway, regarding this particular shape, we are starting with title. Title, it should represent the manuscript. It should be concise and better to avoid long descriptive. Abstract, abstracts generally compete for attention in on or offline databases. We have to remember many more people will read the title than the abstract, and many more will read the abstract than the whole paper. This means that however good and well written the abstract is, it needs to have independent validity. It should make sense as a standalone, self-contained description of the research article. Readers should be able to understand the key points and results of the research even if they never see the whole article. The abstract in this sense is a representation of the research article. Better not to include self-abbreviated term. That is the key word to uplift your quality of abstract. Keywords, we know we have to include keywords nowadays. It should represent the arena of the manuscript. Now I am coming to introduction portion. This is really interesting. These four factors we have to focus on. One is tense pairs, signaling language, second one, and third one is passive or active, and use paragraphing. Generally, tense pairs present simple describes a permanent situation. Suppose the preparation of tailor-made membrane is an art. That means it is present simple. Present continuous describes a temporary situation. Because of this, the present simple tense is used in science writing to state accepted facts and truths. And another aspect is past simple, and with the past simple, you can include present perfect. However, suppose one example is, suppose I have underlined that is, however, one sentence, however, although the effect of the rubber particles on the mechanical properties of copolymer systems was demonstrated over 2 years ago, little attention has been paid to the selection of an appropriate rubber component. That means past simple and present perfect is included in this particular sentence. And another thing is just past simple as well as past simple. That is, however, although the effect of the rubber particles on the mechanical properties of copolymer systems was demonstrated over 2 years ago, little attention was paid to the selection of an appropriate rubber component. That means past simple and past simple. That means authors will need both and need to know when and why to switch from one to other. And this is really interesting regarding the second point, that is signaling language. We know, of course, some about this, but terminology is, I think, it is new to our scientific researchers. That is, the space between a full stop and the next capital letter is a dangerous space for the author and the reader. What is signaling language? Just suppose one example is using the topic. One way to toughen polymers is to incorporate a layer of rubber particles. As a result, there has been extensive research regarding the rubber modification of polylactide. That means topic we are repeating to second sentence. That means signaling language is this type. Using pronoun. Many researchers have suggested ways of reducing costs without affecting the quality of the image. Second sentence is these methods rely on data structures built during a pre-processing step. That means pronoun is used. Sometimes semicolon is also used. We know each and everything, but I am pointing out the particular thing, what we want to do, what we not do actually in terms of our quality development, in terms of scientific paper writing. Using semicolon, the procedure for testing whether components are operationally safe usually takes many hours, semicolon. This means that tests are rarely repeated. Similarly, using relative clause, that means which offer you can continue your sentence. Cause the experiment was unsuccessful due to the measuring instruments were inaccurate. Result, the measuring instruments were calibrated accurately. Therefore, that means therefore is included to join the sentence signaling language and contrast. Suppose Gujarati students are all vegetarians, whereas Bengali students take fish every day. Passive active, we know that particular thing. I am pointing out something different. In the introduction, one can usually say what he will be doing or presenting in the research article. One can use we to refer their research group or team to their research. I am repeating, to their research group or team, but not use it to refer to people or humanity in general. If anyone is referring to people in general, it is better to use construction with it. It is known or it is thought that similarly, rather than we know or think that. It is also common to use the passive instead of we, especially in the central report section, that is was measured, was added, etc. This is related to passive or active. Using dummy in place of I or we. We know that particular whatever sentence I have displayed, that is all we use this type of things. This article describes the membrane preparation pathway. Paragraphing. Paragraphs are an important visual aid for effective reading and writing. Two common errors we are doing, that is, one is clusters of short or single sentence paragraphs, and another is paragraphs that are too long. Both errors will confuse readers and are signs of poorly organized writing. This is another part. This is methodology. We know we have to include methodology in the particular scientific research writing. The methodology should contain sufficient detail for readers to replicate the work done and obtain similar results. It should focus on general overview by outlining the parameters of the work. For example, the number of tests, the equipment, material software used, and perhaps also the purpose of the investigation. This helps the reader to get a general idea of this section. Provide background information about the materials or about the source of the materials or equipment. Refer back to something in the previous section. Common options are restating the aim of the project or the problem authors are hoping to address. In some cases, authors begin immediately with a description of the procedure or the materials. This is appropriate where the research focus is very narrow and all those who are likely to read it are carrying out similar research. Here I am displaying two sentences. That is, one is present simple passive. A flexible section is inserted in the pipe. It uses present simple tense to describe what is normally done or to describe a standard piece of equipment used. And another is a flexible section was inserted in the pipe. That is past simple passive. It signifies the past simple tense to describe what authors did. That is the difference. Methodology in brief, that is, provide a general introduction and overview of the materials or methods and give the source of materials or equipment used. Second one is supply essential background information. Third one is provide specific and precise details about materials and methods, quantities, temperatures, duration, sequence, conditions, locations, sizes, everything should include. Justify choices made. Whatever we have taken for the conditions, that we have to justify there. Indicate that appropriate care was taken. That is also should be highlighted. Relate materials or methods to other studies. Indicate where problems occur. Another thing is whatever I am displaying regarding a and the use in some examples, that is a is for general reference. Suppose there is a polymer on the shelf above my desk, and second one is the. We removed the softest layer of the membrane. That is specific reference. That means a and the should be used for your requirement in particular situation. Results and discussions. We know that results and discussions includes these four factors: sequence, frequency, quantity, and causality. Sequence means for scrutiny of other researchers. In order for other researchers to be able to repeat authors' work accurately and compare their results with authors, authors need to be able to describe the order and time sequence of what they did and found in a very precise way. Time sequence means how long each step it took and where it occurred in the sequence. Similarly, frequency, it is also important to communicate clearly how often a particular event or result occurred. If a particular result occurred on every occasion a test was carried out, then it is a very reliable result. If it sometimes occurred when the test was carried out, that is a less reliable result. Is also important to communicate clearly how often a particular event or result occurred. quantity in terms of your words as well as your graphs, figures, tables. We have to explain our figure. Words have surprising power and can encourage people to form strong impressions. The language authors use to describe their results have as much power as the tables or figures. Perhaps even more. Look at the two structures figure in the figure, that is two pesticides I have portrayed, but they are structurally different. We have to explain this. Results do not speak for themselves. We have to explain where it is the difference. Anyway, causality. That means the relationship or connections between the events that authors observe. Do the authors need to compare their results with those of other researchers? One direction is to report authors' results only. Another direction is map your research with others or worldwide research. This is summarizing, revisiting the research aim or existing research, general overview of results, invitation to view results, specific or key results in detail, comparisons with results in other research, problems with results, and possible implications. These are the particular whatever I told you regarding the scientific writing in terms of methods and methodology, abstract as well as result discussions. I am writing now summarizing key points to this particular manuscript writing. This is preparation is the key. It is better to do some research before writing. Better to take the time to think over all the things associated with it. Be your address. A key technique to use when writing anything is to clearly visualize your readers. It is better to imagine author's mind eye, the specific persons to whom their written product is directed. Better to make an effort to see the situation from the other person's perspective. Shorter is always better. It is always better to cut down in length, better to concentrate on conveying the essential message, short and to the point, to get the author's message read. Outline first, logical thinking regarding the coverage. Write and then rewrite. Always there should be some direction for successive improvement of the draft. And in this aspect, I can brief you one article I have read regarding whatever we are writing, that is rewriting one. We are not writing whatever in our self style. We are copying, we are rewriting from particular whatever our impression in regarding the manuscript writing. We have to self-style. But remember, this particular strategy we have to follow. Format is important. The format should look professional. And another thing is concise language for clarity and precision. Short sequences are preferred. Inappropriate language is not preferred. Simple, straightforward paragraphs exceed or equal to 10 sentences generally. The language and terminology should be familiar to the intended recipient. Technical terms and acronyms should be explained first unless it is certain that the addressee is familiar with them. We generally forget whatever in our research writing. Sometimes we are using technical terms, it may be unknown to readers. That is this physicist Louis Amarlal, Northwestern University, told that distinguishing between technical and general jargon isn't easy. Another quotation is there: opacity on a habitual, almost ritualistic use of power words such as distinct and noble. That is, we sometimes unknowingly use distinct as well as novel, though it is known. Uh, these are some misused words sometimes in the manuscript. Um, I am pointing out few words regarding this topic. Uh, Suppose accept and accept. These two words sound similar but have different meanings. Accept means to receive something willingly. His mom accepted his explanation, or she accepted the gift graciously. Accept means inclusion, exclusion. I can attend every meeting except the one next to it. Similarly, affect versus effect. To make these words even more confusing than they already are, both can be used as either noun or a verb. As verb, affect means to influence something or someone. Effect means to accomplish something. Your job was affected by the organizational restructuring. That is affected. But these changes will be effected on one day. That means it will something different, whatever your particular language. If you use affected in place of affected, your particular meaning or your sentence's meaning will be different. Anyway, as a noun, an effect is the result of something. The sunny weather had a huge effect on sales. It's almost always the right choice because the noun affect refers to an emotional state and is rarely used outside psychological circles. The patient's affect was flat. Similarly, lie versus lay. We are all pretty clear regarding the lie word. That means untruth. It's the other usage that trips us up. Lie also means to recline. Why don't you lie down and rest? Lay requires an object. Lay the book on the table. Lie is something you can do by yourself, but you need an object to lay. Past tense, it is confusing. Suppose lie, your past tense is lay. I lay down for an hour last night. And the past tense of lay is laid. I laid the book on the table. Similarly, fewer versus less. Use fewer when you are referring to separate items that can be counted. Use less when referring to a whole. You have a fewer paise but less money. Similarly, bring versus take. Always we forget this particular use of these two words, bring and take, both describing transporting something or someone from one place to another. But the correct usage depends on speaker's point of view. Somebody brings something to you, but you take it somewhere else. Example, bring me the mail, then take your shoes to your room. Just remember, if the movement is toward you, use bring. If the movement is away from you, use take. Imply versus infer. To imply means to suggest something without saying it outright. To infer means to draw a conclusion from what someone else implies. As a general rule, the speaker or writer implies and the listener or reader infers. Similarly, comprise versus compose. These are two of the most commonly misused words in the English language. Comprise means to include, compose means to make up. It all comes down to parts versus the whole. When you use comprise, you put the whole first. Example, a soccer game comprises, that means includes two halves. When you use compose, you put the pieces first. 50 states compose, that means make up the United States of America. Another one is, this is related to further and further. Further refers to physical distance, while further describing the degree or extent of an action or situation. I cannot run any further, but I have nothing further to say. If you can substitute more or additional, use further. This is related to my know-how regarding the mouse invention. This is computer mouse, prototype created by Douglas Engelbart and Bill English. And whatever I wanted to point out, this is another terminology of computer mouse. Most of us, we don't know regarding this particular terminology. That is XY position indicator for a display system. That is also synonymous with computer mouse. Suppose in particular discussion, one can write this particular thing, whatever you know. Apart from that, this another meaning is there, then it will be difficult. That's why understanding as well as synonymous words should know before writing everything. Anyway, this is my last slide. This is Ajim Premji's words. Remember, those who win are those who believe they can. Thank you.
Thank you, sir. I request if anyone have any question, can ask.
It is completely different topic. One cannot teach the particular strategy of manuscript writing. You have to learn by yourself. You have to read first. So many research papers you have to read, so many articles you have to read before your writing expedition. I better I tell it. It is expedition to manuscript, scientific manuscript writing. Anyway.
Thank you, sir. Thank you for your valuable knowledge. Thank you for sharing it with us.
Thank you. Should I leave?
Joyita ma'am,
Yes, ma'am.
sir is asking if he can leave.
Hi, yes, sir. Yes, sir. You can leave, sir. Thank you, sir. Thank you. Now, Shri ma'am,
Yes, ma'am.
I think our next speaker has not yet been joined.
Okay, ma'am.
Okay. So, in that case, we can take 15 minutes break.
All right, ma'am. We all
start
can join
1:30.
after.
Yeah.
Yes, ma'am. We all can join by 1:30, 1:35.
1:30. Positively by 1:30. Okay.
All right, ma'am.
Yeah.
Thank you, sir. It's my privilege to formally introduce our third speaker of day 2 of this FDP, Dr. Professor Ananda Datta, sir. Professor Dr. Ananda Datta received his PhD from Jadavpur University, Kolkata in 1998. His area of research is ultra-fast processes in molecules and materials. He is currently associated with IIT Bombay. Earlier, he was a visiting scientist at Raja Ramanna Center for Advanced Technology, Indore. He was a postdoctoral researcher at Iowa State University, USA. He has received several awards and recognitions like Young Investigator Award from IIT Bombay in 2005, Young Researcher Award from Chemical Research Society of India 2006, G.V. Bakure Memorial Award from Indian Chemical Society 2011, Award for Excellence in Teaching from IIT Bombay 2017, Fellowship from National Academy of Science India 2017, and Bronze Medal from Chemical Research Society of India 2018. He has guided 21 PhD and 41 MSc students along with 7 postdoctoral fellows. He has 143 publications and 2 book chapters. He is also a guest editor in Wales Journal. He is a member of editorial advisory board of the Journal of Physical Chemistry, Facility Management Committee, SAIF, Harvard University. He is the president of Fluorescence Society of India, vice president of Indian Laser Association, member executive council, Indian Photobiology Society. He was also a visiting faculty member at IIT Goa. He has also guided many students across India through online NPTEL courses. We welcome you, sir. Kindly share your valuable knowledge with us.
Thank you, ma'am. And let me start with an apology. I was supposed to have given this talk at 10 a.m. today, but then age is catching up. So I ended up committing to 2 things at the same time. And Joyita ma'am was kind enough to let me reschedule the talk. Thank you, ma'am, for that. It's of course a pleasure being with all of you and sharing our experiences. To start with, I have to thank ACS because the slides that I'm going to present are actually made by ACS people. I thought I'll use them because then, you get an idea about their thought process. We are trying to talk about how to write a manuscript, effective manuscript writing. At the end, I'll also talk about how to write a proposal. I don't have slides on that today, but what we discuss from these slides will apply by and large there as well with some additional features. And of course, it's a pleasure to be associated with anything to do with Ranchi because my son actually studies in Ranchi. He's a student of a BA-LLB program of NUSRL Ranchi. So that is an additional personal point of interest. All right. So this is, as you can see, this is something I presented as a part of a DST ACS publishing workshop held in Bharati Darshan University, Trichy, in 2019. So from the date you see, that was before COVID hit and our lives were turned completely over its head. That was a time when we did not really know how to make online presentations and stuff. I have a request for the audience. If you have a question, please don't hesitate to stop me and ask, right? That way, if it is interactive, then I think it will be mutually beneficial. All right. We are in this business of scientific research. And the moment you do research, of course, you are going to get results that you have to share with the world, right? Otherwise, what is the point? And the way most of us share our research with the world is by writing papers. And while doing that, it is very important that we write our paper in the right way. And there is no one right way, but there are very common pitfalls that one should avoid. And there are ways in which we can improve our manuscript so that it has a better chance of being accepted and circulated worldwide. So in a nutshell, these are the things that the publishers look for or the scientific community looks for in a high quality research paper. And let me reiterate, these slides are made by ACS people. So I'm just voicing the opinion or the thoughts of one of the leading publishers in chemistry. So it's sort of from the horse's mouth, even though it's not narrated by the horse. So first of all, we all understand that when we write a paper, it is not a compilation, right? It's not a scientific report of some experimental observation. But rather, there has to be a detailed analysis. Yeah. So otherwise, why do you need scientists? I mean, anybody can do research. I mean, most of the research can perhaps now be done by robots. The reason why we do it is our brain is the most important instrument that we can have. And our paper must manifest an ample usage of this brain, not only to perform the research and compile the data, but also to analyze. I'm going to elaborate upon each of these points later on, but to put it in a very succinct manner, the title and abstract have to be simple and attractive. And the figures and schemes have to be well done and self-explanatory. Sometimes we think doing the experiment is good enough. We may not pay so much of attention to this, but it is important. Everything is important. Pehle darshandhari, piche gun vichar. The experimental method section has to provide sufficient detail so that somebody else can reproduce it. Unfortunately, in today's world, people have become so secretive that, especially in fields where it involves making a molecule or making a new material, you see that you can never reproduce any result because some crucial steps are conveniently left out. That is a very wrong practice. And the way, what we do that way is that we hinder the progress of science. The purpose of the paper is not just to add to our CV. Primary purpose is to disseminate knowledge. If we do not disseminate knowledge in a complete manner, then we don't really serve our role as scientists. The job of who is really to take the understanding of human beings a little further ahead. And end of the day, this last point is intricately related to the first point. The paper should tell a compelling and exciting scientific story. We'll come back to these points one by one, and we'll start at the end. It's all about telling a story. If you have read Yuval Noah Harari's book, Sapiens, what he says is that human beings are actually such a weak animal. We don't have powerful teeth. We don't have claws. Our skin is thin. We cannot run all that fast. Why is it that, what is the strength of human beings that has enabled us to rule over the world? First is intellect, and the other, Harari says very interestingly, is our ability and propensity to gossip, to talk to each other and share our experiences. That is what the tigers don't do, or dinosaurs did not do. So telling a story is the biggest strength of the human race. So the purpose of our paper is really to tell a story. So it has to have a theme. Sometimes I have seen students and sometimes even professors say things like, all right, the thesis has to be so many pages, or the paper has to be so many words, or you have to have so many figures. So all that is not true. It is not really it is not a question of putting a lot of things into a paper. The purpose of the paper is that it should say what you have learned about the experiment you did or the calculation you did or whatever. So it is very important to avoid data dump. Very often, people feel that if you put in a lot of data, you do this, do that, many other techniques, the paper will get through. And unfortunately, sometimes it does. But that paper is completely useless. What is the story? What is the theme? What do we learn? That is the main thing about writing a paper. It is very important to cite the papers that are relevant, because we don't do anything from thin air, right? Newton had said, if I can see a little further ahead than others, then that is because I'm standing on the shoulders of giants. All of us stand on the shoulders of giants of different size. Yeah, we have the benefit of hindsight. As one of my teachers had said, every piece of research is really a linear combination of previously performed research plus something new. So it is very important to not ignore what is already done. You have to provide in the introduction this context of your paper. Sometimes some of us are afraid that if we say that so much of work has been done, the reviewer will think there is nothing in this paper and will reject it. Well, we should not do research that would put in that position. Yeah. So we have to be brave and we have to cite what is it. We have to say the whole truth. We have to cite the original work in the reference section. I know of a very good researcher in a very prominent institute who got into trouble because two of them, he and somebody else in another institute, were working on the same problem. The other group published first. The second one, it was not really their fault. For whatever reason, their experiment came a few months later. The mistake they made was that they published another paper without citing the previous one. And all hell broke loose after that. Letters went to the head of the institution of this scientist. They had to write not a retraction, but they had to write a corrigendum to their paper, citing the original paper and saying that we had missed it out inadvertently. And generally, that it gave rise to such a lot of bad blood that it affected both the parties adversely. That is something that we must avoid at any cost. For two reasons. First of all, the primary duty of a scientist is to speak the truth. When you speak the truth, you have to speak the whole truth. You cannot leave things out convenient. Secondly, when we cite literature that's already there, then only we bring out the importance of our present paper. Right? Otherwise, the audience may not understand why we have done what we have done. So why is the problem important? That comes out with appropriate citation. So that's first point. The second point brings us to the methods section, materials and methods. Experimental details have to be shared in such an extent of detail that somebody who more or less knows the field should be able to reproduce your results. If others cannot reproduce your results, then the results should not have been published. That is very important. Once again, somebody got into, not somebody, many people have found themselves in sticky situations because their results were not reproducible by others. Now, if you don't provide sufficient experimental detail, how will anybody try to reproduce it? It's very important that we give sufficient details. The data analysis is something that has to be done in person. Now I can take names. Millikan's oil drop experiment. All of us would have studied in physics. Millikan's notebook was found in his lab after he passed away. And it was found that he had done his oil drop experiment, I've forgotten how many times, few hundreds of times. And actually, for several of those times, he got a result that was very, very far away from what is finally reported. And he did not consider those. He might not have considered those for good reason, that the experiments were not done properly or something. But we cannot analyze our data thinking that this should be my result. In fact, if you think that this is what we should get, if you are biased in your thinking, you might see it. And we might see something that is not correct if our vision is blurred by our bias. So even if the data does not support our hypothesis, we have to be truthful to that. Max Planck had said experimental results are the only truth. Everything else is poetry and imagination. So data analysis is sort of poetry and imagination, but it has to be done on the basis of truth. That is the data as it is. Data fudging is an elephant in the room. As many of you would know, data fudging is their reality. People do it. And there was a time when many groups would conveniently modify the NMR spectrum. Peaks that were not all that convenient would be there. That is why most of the journals now ask for the raw data, right? The decay. So we have to be very truthful about the data, and analysis has to be according to what it is, no matter how inconvenient. And finally, there has to be a conclusion. Here, I see in many places, and I have to keep saying this to students especially, when they present their work or when they write their paper, the conclusion is merely a summary of what they have said in results and discussion. No, that is not what the conclusion is supposed to be. We all know that the dictionary meaning of conclusion, right? It is the end of the paper. It is what says what we have learned from the entire exercise. So you have to say how it has helped to, how it has added to the understanding in the field. But by saying that, we should not let our emotions drive us so much that we end up saying that this is something that will completely change the field. We have done this experiment, and now that we have done it, high temperature superconductivity is a reality. Tomorrow you can start using it. Electricity bill will become zero. We should never go to an extent where it is not realistic. Here also you have to be objective, but you have to say how the field has moved forward. It is okay to write. So from here, we think this is the prospect. These are the experiments that can be done. It's good to write that. But again, to conclude the discussion or conclusion, it should not be a mere summary of what has been stated already. It should say what you have done. It's okay to say the future scope, but it should be realistic, right? Too much of speculation, well, not too much. Speculation is definitely a good thing to include in conclusion. Now, we are all familiar with the anatomy of the manuscript. First, you have title, then you write the abstract, introduction, graphics form a very important part, experimental section, results and conclusion, references, and acknowledgement. You write this manuscript. We'll come back to this anatomy later on. But let us now address another question. Where do I submit it to? There are people who submit the work to the journal with the highest impact factor that they know. And that is an absolutely wrong approach. There are so many journals, right? Here, of course, since it was the slides were prepared by ACS, what you see here is a list of ACS journals. So I've written a paper. I will always submit to JAX to start with. And then when it is rejected, will I send it to maybe ACS catalysis? If it's rejected from there, will I send to organometallics? Even though the work may be something that is absolutely suitable for JPSChem A. No, we should not. If you have done something which is of interest to physical chemists and nobody else, I should send it to the appropriate part of Journal of Physical Chemistry. Okay, ACS Omega is an open access journal. For example, there are equivalents in from other publishers as well. RSC Advances, Chemistry Select. So these journals were conceived with a specific intention. See, now the body of scientific literature is so vast that you can have many papers that are technically sound and maybe useful for somebody to do some experiment when they read it, but they're not novel. So ACS Omega, RSC Advances, Chemistry Select, these are journals that were conceived to publish such papers. It has to be, all experiments have to be done correctly. Experiments, calculation, whatever. But if it is not so novel, those are the right places to send. But suppose you have done something that is, you have worked on middle ion complexes where you have non-innocent ligands. The right journal definitely is inorganic chemistry. But if the same complex can be used to do some interesting catalysis, then you can consider ACS catalysis. But just because you have made a complex, you should not send to ACS catalysis right away. Okay, so that is where we have to use our judgment. And the most important thing there is we must know the scope of the journal. For example, ACS Applied Materials and Interfaces, very good journal. Many of us would love to publish there, but it's important to understand that the scope of this journal is applications. The name says it, right? ACS Applied Materials and Interfaces. First of all, your paper cannot be an organic synthesis. It should be a synthesis of materials with synthesis. Or it should be something you've done at the interfaces, and it should either be a direct application or with something with an immediate or potential in application. Otherwise, ACS Applied Materials Interfaces is not the right journal to send you. Maybe it's a good journal for, maybe it's a good paper for, again, Journal of Physical Chemistry or Langmore or something else. How do you know what the journal scope is? Experienced researchers know already, but it's always good to go. All journals have links like this. And when you click, you get a page that tells you what kind of papers this journal is looking for. Please check that before deciding upon which journal you should send it. It cannot be based on impact factor. Before sending, every journal has its particular format. So please read what kind of format is to be followed and how you're supposed to write it. Plagiarism is something that is an absolute taboo thing, not only with ACS publications, but with all publication houses. So make sure that you write things in your own language. Especially students, when they write their first papers, they have a tendency to copy-paste the experimental section from already published papers. And we have to correct them. You cannot say it is okay to copy-paste on some, even your own papers. You have to rewrite in your own language. And always cite. It is better to cite a few papers more than a few papers less. Okay? As they have said, in no uncertain terms, most plagiarism cases involve copy-pasting in experimental sections from your own paper or from other papers. So let's be careful. And sometimes now I see writing a review is a fad. I went for some interview somewhere, and people who have not really done much of original work, they say we have published 20 reviews. And I wonder how. I have not published so many reviews, hardly published any. So please, it's okay to write reviews and all, but please make sure that the journal you are sending your review to is okay with unsolicited reviews. Again, since we're talking about ACS Applied Materials Interfaces, they don't accept review papers unless they have specifically asked for it. Right? So don't get crashed. Make sure that you have an invitation if you have to publish a review there. So the steps that we need to follow in composing a manuscript is, first of all, we have to create an outline and identify the major scientific advances. Bullet points are a great way to start, right? And then it's always good to think that what will I write? What will I write? In fact, it is always good to start here. Figures and schemes. Even before trying to write anything else, it's good to jot down bullet points and say that, okay, this is what I have seen. Then decide how you prepare the figures. It is not good enough to just give whatever comes out of your computer. You have to draw your figures in such a way that they communicate the story that you're trying to tell. Will take some time. Then, once you've drawn the figures, it is good to write the results in according to the figures. And when you try to start with, just try to describe what each figure says, and then try to discuss why that is important, or what is the new thing, what should be done next. That way, it is easiest to write the results and discussions part, I think. And then it is better to write the introduction. The abstract must include highlights. I'm going to show you some examples of abstracts shortly. So finally, with all these, we should compose a scientifically effective paper. And again, we have to keep the journal scope in mind. How to create the useful outline? First thing to do is to gather data. Whatever you have got, as we all know, when we try to write a paper, there is a sea of data from which we have to choose. We cannot publish everything that we have taken. You have to choose the data set that we have. Then we have to do analysis, calculate averages, draw plots, do a lot of things. So first step is to collect the data and then ask, why have I got this kind of plot? Why does it go up, not go down? Why does it go through a maximum? What is going on? And how can I explain? And then you organize the data in order of importance, not necessarily chronology. Very often we have the tendency of saying, okay, we have done this experiment. Since I'm a spectroscopist, I'll go in that order. I'm going to show the absorption spectrum first, followed by fluorescence spectrum, followed by fluorescence decay, followed by transient absorption. That may not be the right way in some cases. Sometimes you might have to start with fluorescence spectrum. Sometimes you might have to send the absorption spectrum into the transient absorption data later on. So organization of data in the way to best to be able to tell the story in the best possible way, that's very important. Draw the figures, think where they should appear. Where the figures appear is also important. You write something about figure 5, and figure 5 is 4 pages later. So how is the reader going to find it? How is the reviewer going to find it? So organizing the manuscript is also important. Remember again, Pehle Darshan Hai. So review your outline with a colleague to see if you missed a key point. When the colleague doesn't mean another professor, your students are your colleagues as well. So it is very important to be a team player while writing papers. Okay? And start outlines early in the project. Don't wait until the end. It should not be that you collect everything and then start that. It has to be a continuous process. Next, we come to the title. Sometimes we think, what is the title? It's very important. It draws the attention. And here I want to again highlight something that I suppose many of us would have faced. When we try to publish a paper for the last 10 years or so, many times we have what is called desk rejection. It doesn't even go out for review. After 3-4 days, the editorial office says, no, I don't think this paper is all that good for our journal. Why don't you try elsewhere? Now, most of the time, this decision is finally, usually it is taken by an editor, but they have people like associate editors or editorial assistants, development editors, who do most of this desk work. So what they do is they have certain algorithm. These people who are not editors, who work for the editors, they read your paper and prepare a report for the editor. It is like a junior lawyer preparing a brief for the senior lawyer. And they have certain red flags. Remember, the slides are made by ACS, so we are getting an insight into what they think. It is very important in the title to not write study or investigation or demonstration, because they have handled lakhs of papers actually, and they have done a systematic study. What they found out is that most of the papers where no new scientific advancement is there, only some routine work is there, they say study of this, investigation or demonstration. So now what happens is that this assistants of the editors, whenever they see this word in the title, they flag the paper for desk rejection. So if you want to get your paper reviewed, please don't write these words. So these are no-nos. Okay. Avoid asking question in title can be debated. The reason why they say don't ask a question is that the audience doesn't understand what the answer is. Is it this way or is it that? And it is very important to avoid future problem. It's very important to avoid claims of priority, originality, convenience, or value. Okay. So another thing, the title should be grammatically sound. Earlier today, I was in a meeting, and then somebody made a presentation. The slide title is when it has wrong grammar. That doesn't look good. Okay? And that creates a negative impression which can lead to rejection. They might think this guy doesn't know what they're talking. Okay? And compelling title, we'll come to that. But before that, more taboo words. Don't use the words convenient, efficient, elegant. Expedient, facile, fast, new, novel, practical, simple, unique, unprecedented, versatile. You might be thinking, what will we write if you don't write all these things? Figure out a way, because the moment you write these things, your paper is very highly susceptible to desk rejection. Right? Okay. What is the purpose of the title? The purpose is to attract a potential audience. And also, when somebody searches, somebody wants to search for shift-based fluorescence, your search engine should be able to pick it up. So the name cannot be very vague also. Yeah. So the content has to be simple, effective, accurate. And what the editors think is that you cannot have adjectives that are too long. Now, let's take some examples. First title, and just think how many papers you have seen with titles. Synthesis, electrochemistry, spectroscopic characterization, and X-ray crystal structures of nickel-3 complexes that can be isolated and promote. First of all, there is a grammatical error here. Isolated and promote carbon-carbon bond-forming reductive elimination. By the time you reach the end of the title, you have forgotten what the first word was. And also, this kind of a title sort of gives the impression to the editorial team that this is just a compilation of results. There is no real story. So the same thing can be said in a much better, succinct way. Right? Now let us see what the alternate title is. Carbon-carbon bond-forming reductive elimination from isolated nickel-3 complexes. Right? That's short and sweet. The titles don't have to be short always. We'll see some examples of those as well. But just compare these two. So they sort of are talking about the same system, but the second one is so much more better. Some of you might know this story of Kalidas, and I forgot who the other guy was, Vararuchi or Bhavavuti. Let's just say Vararuchi. Vararuchi went and complained that I am also a poet. Nobody talks about me. Everybody is going gaga about Kalidas. Why is that? So the king, Vikramaditya, gave them a task. He got hold of a dead branch and kept it in front of his throne, asked both of them to write a couple of lines of poetry about it. So the other guy wrote, Shushkang Kashtang Tishtadi Agre, which is accurate. But it sounds really dry, like Shushkang Kashtang Tishtadi Agre. Kalidas wrote, Nirasa Taruvar Purata Bhage. The same thing, but sounds so much better. It is important. You are also trying to sort of sell your paper to the audience, right? You want the audience to read it. Now, if they spend so much of effort in reading the title, they'll not read the rest of the paper. And also, the paper may not be published because your editorial team might think that it is just a routine work. So, a lot of thought has to go into the design of title. First of all, it has to be compelling. Secondly, buzzwords are best avoided. There cannot be intriguing short forms in the title. Avoid asking a question in the title. That's the thing with the publishers. I differ, but well, I don't have a say in getting a paper accepted. They do, so better follow what they think. And it's always, this is something that happens with us always. Keep on changing the title. Write something to start with, and then after a while, after discussion, after writing the paper one more round, that might change. So we should not write a title at the beginning and stick to it. Okay. Another example. Synthesis, electrochemistry, spectroscopic characterization, and X-ray crystal structure of a novel NAC-NAC-LA complex that attacks DNA and cures cancer. So the title does tell you what it is about. And if you read it maybe twice with some patience, you understand. But look at the alternative title. Lanthanum 3-diketiminate complex cleaves DNA at nanomolar concentrations. That's beautiful. Tells the entire story in so many less words. I mean, you might have forgotten what NAC-NAC is, right? So that is a very nice example of how a title can be better or worse. Well, I think this is a title of the paper that was published in Chemistry Materials. And the other one is a bad title that the ACS team made up just to demonstrate. And here you have some titles that have been handpicked by editors. They think these are great titles. Let's see what they read. Synthesis and spectral properties of 8-anilinothalene 1-sulfonic acid, that is ANS derivatives, prepared by microwave-assisted copper-0 catalyzed Ullmann reaction. So see, this title is long, but you can read it. You don't have to read it twice to understand the meaning. Evidence for a catalytic strategy to promote nucleophilic activation in metal-dependent RNA-cleaving ribozymes and 817 DNA enzyme. Clear, even though long. Let's now see an example of a short title. Halogen bonding beyond crystals in material science. I think it's a review. Actually, review titles can be much shorter, but it's crisp, right? It tells you what the paper is about. Interfacial diffusion printing. Using colons is actually a good idea, where before the colon, you present maybe a little broader area. After the colon, you present a more specific phrase to describe the paper. Interfacial diffusion printing, an efficient manufacturing technique for artificial tubular grafts. Very clear. So there are some other examples. I'll not go through that. Let's come to the next point. After title, the other thing is table of content image. These were not even there when I was a PhD student. In fact, it was not even there in the early years of my independent research career. But that was a time when the number of papers published were 2-3 orders of magnitude less. Now we are competing with each other all the time. You want your audience to read the paper, and more than that, even more important than that, start with, you want your paper to go out for review. And one of the things that the editorial team uses to do desk rejection is table of content image. So just by looking at it, you can have it should be such that your reader has a rough idea about the paper. Okay? It has to resonate with the title, of course. And it has to provide a sense of what has to be learned. It should be something that is that can be understood quickly and exciting as well. And this is a very common mistake that perhaps I also have done at the beginning, to cut and paste one of the figures or reaction scheme to use as TOC. Now, this sends out a message to the editorial team that you are lazy. You don't even want to invest enough time to draw a decent image that is so important. Please don't do that. Draw separate images as far as possible. Here are 2 examples of good and bad TOC graphics. Okay? And here is a recommended reading where you can get an idea about how to make TOC figures. So one trap that sometimes we fall into is use of cartoon images. I mean, in our attempt to make it attractive, we make it too funky to be acceptable as a scientific communication. So let's be aware of that. And usually this rule is that no logo from university, government associations or companies can be used. Why? Because that might be seen as an effort to influence your reviewers. Just look at the good example first. Here it says, when is this Na3-SBS4 interface unstable and when is it stable? I have not read the paper. Okay? I have no idea what it's about. But looking at this, let us see if we can understand. What it says is that you have this Na3-SBS4 in both the cases. In one case, you have sort of a mosaic on it, in which you have different things, sodium sulfide into SBS, so on and so on. When you have something like that, you can have an electron escaping and you can have an electron transfer. And that is what makes the interface unstable. On the other hand, if you don't have this mosaic, if you just have a coating of CpEO, that effectively stops electron transfer. Whereas sodium ion exchange is still there. Okay, on this side of sodium, of course. That is why this is stable. See, without reading the paper, without knowing anything about the paper, we can sort of guess what it's about. Now look at the right-hand side figure, which actually looks much better. Right? But what does it mean? Because somebody is doing magic. and there is some Taj Mahal kind of thing. Is it Taj Mahal or is it something else? I cannot make out. Something like Taj Mahal. So if there is daylight, then you can hardly see it. When UV lamp is on, you see it very well. When UV lamp is on, you see it a little less well, maybe, but I'm not very sure. So the magician is smiling in all the three cases, identical. And what is the meaning of this guy saying wow and this girl saying wow from the two sides? So it is almost like canned laughter. In television series, sometimes you see this laughter of the audience is also played from time to time. But I have to tell you that now you can laugh. That was funny. Yeah, that's all. This figure is almost like that. It's a good-looking bad figure. Whereas on the left-hand side, you have a figure which is very good. Another example of a figure which is not at all funky, right? This is like plain vanilla kind of figure, but look at it, you'll understand. You start from here, you add this compound, you get Fe3O4 nanoparticles, and you can see. So here they're using data. Not only that, the right-hand panel tells you that it has some kind of an application in MRI. Now read the title. Water-soluble, super-paramagnetic magnetite nanoparticles with biocompatible coating for enhanced magnetic resonance imaging. So even though this TOC figure is not really colorful or any such thing, tells you the story, it's effective. Some more examples. This is one. Flash synthesis of CDSA. So you start with CDSA. You can see 10 nanometer, right? So very small nanoparticles. Add whatever you have to add, wait for 3 minutes. There's a CDS shell, which is much bigger. And you can see how fluorescent it is, how photoluminescent it is. This one is interesting, even though it is a little dated. 2014 was long ago. So it doesn't really look, I'm sure there are better ways of drawing the same figure now. But see, you have something that is a pristine thing, and you deposit something else on top of that. You can have half charge and you can have overcharge, which means you have more coverage. And that is reflected by this energy loss spectrum. So it tells a story. Now, here are some examples of TOCs that are bad. I've spoken for a long time. Let us see if you would like to speak now. Who is going to tell me why figure A is a bad figure for TOC? Can anybody unmute and say why you think this is a bad figure? Okay, I'll tell you. See, first of all, the choice of color is horrible. It's hurting the eye. Secondly, what is there? Let's try to understand this silicon, and then you have something, some gold on top of that. And if you're applying high partial pressure, fine. And then what you have on the left side is critical silicon nucleus, that is this. And effective chemical potential of silicon in the nanowire increases. And what is this? Perhaps this is what. So you are left wondering what this is. And it doesn't really look all that good. Look at B. It is some ATR, FDR spectrum, very unattractive. Same is the problem with D. And looking at C, what is it? Looks like it is some kind of an MD simulation or some such thing. But of what? Is it a protein? Is it something else? Some molecule is there? Nobody would understand anything. So these are not good TOC figures. All right. Maybe, madam, do I have 10 minutes more or 5? Something like that?
Yes, sir.
Okay, fine. I think I'll be able to finish by that. Abstract. See, you have to summarize your work in this abstract, and not only do you have to attract the reader, but also you have to attract again the editorial team. And again, words like superb, excellent, exceptional, outstanding, let your audience say it. You don't say, I'm the best scientist in the world. Leave it for others to say. You do your work and let your work speak. So those things, usually when you write those such words, it's a put off for your audience, better not say. The purpose of the abstract is to allow readers to determine the scope of the paper and also to help retrieval and indexing. The content has to be concise, self-contained. You should not supplement or evaluate the conclusions, and In abstract, you're not allowed to cite references, tables, figures, and let's see some examples. Here you see this is such a beautiful abstract. The abstract is written by the authors. The color coding is done by your ACS team. You clearly have a background. Methodology. In this work, we develop a computational methodology to examine the thermodynamics of formation resistive interfacial phases. Then you have major conclusions. Predicted interfacial phase formation, well correlated, this, that, passivating, ironically conducting barrier. Finally, you have closing remark. As a reference for experimentalists, we tabulate the stability and expected decomposition products for a wide range of electrolyte, coating, and electrode materials, including a number of high-performing combinations that have not yet been attempted experimentally. This is beautiful, and it cannot be better than this. So nicely structured. Okay? You read this abstract, you'll feel like reading the paper in case you're in that area. Another one. Again, you don't have one drink to rule them all. There are different ways of doing it, but you have to do it in a structured manner. Here you see what they've done is, you go back to the earlier one, started with background. This one doesn't. It starts with the purpose of the research, motivation. Then a couple of sentences about the methodology, much less emphasis on conclusions. And then you have, you say, what is the implication? And even this is excellent. There are some other good examples. Now, that is what I wanted to say about graphics. Abstract. Now let's talk about figures. Figures are the most important things. When I was a postdoc, my postdoc guide used to say that when you draw figures and figure captions, it should be such that if somebody reads the abstract, sees the figures, reads the captions, and maybe looks at the tables, they should not have to read the rest of the paper. They should get an idea about the work, right? Because who has so much of time? There are thousands of papers coming out. So this is very important. Your figures must tell a story. Again, there is a good graphic and a bad graphic. Why is it a good graphic? Because first of all, look at the fonts. You can read everything. Here, look at the inserts. Can you read without zooming in? I cannot. I sort of can guess what is there in the insert because the data is similar to the data that we also produce, but it doesn't really tell a very good story. And then can you read the y-axis? Not very clear. Font size is all wrong. So you have to familiarize yourself with what kind of fonts to use. I mean, you don't use Comic Sans, for example. Use of color is great, but be sensitive, please, about the fact that there are people in this world who are colorblind. I'm particularly sensitive to this because I am colorblind. So if you use a color combination that a colorblind person cannot make out, then your purpose is lost. You have to do something extra with that. The figure has to combine an accuracy of the presentation of data as well as aesthetics. It should be good looking. Okay? Here you see it is so nice. They have used colors, but they've also written A, B, C, D. Right? A, B, C, D. So even if I'm colorblind and cannot make out the colors, I can read, right? And I should be able to see. The legends sort of supplement the color coding that is there. And also this is great because the main figure is just the absorption spectrum. And the inset is absorbance at 590 nanometer plotted against time. So they don't contain the same information. This figure is at some particular time. So the absorbance is changing with time. So that is what is shown very nicely in the inset. How thick should the line be? How long should the ticks be? All these would come with experience. You have to do it and you have to look at it critically. It's not good enough to just draw a figure and let it be. Using bold, like for example here, absorbance, wavelength, nanometer are written in bold. Please note the other fonts are not in bold. There's a very common mistake to use bold fonts for everything. That hurts the eye and it takes out the purpose of using bold fonts. The purpose of using bold fonts is to highlight. Now, if everything is highlighted, then you need some other way of highlighting the parts that you want to highlight, right? So all bold is a bad idea. And the graphics and figures would better be high quality. Otherwise, this is what, so this is an actual PDF file they have given. Somebody has submitted a paper, you cannot even see the figures that are there. So what will anybody understand, right? So you have to check the PDF file that you're about to upload. Now, we come to the issue of cover letter. Many times, sometimes we may not be aware that this is a very important thing. Cover letter will not get published, that's true. But the cover letter provides you sort of an informal platform in which you can communicate with the editor. You can tell the editor, what is so great about your paper? Why will they consider it for publication? Okay? So this is your one chance of getting the ear of the editor, so to speak. So you have to say, you have to highlight your most important findings. You have to say why it is important. Now, if you copy the abstract, so what this editorial team does to start with, even before the editor sees it, they look at the cover letter, abstract, introduction, and conclusion. If there is substantial overlap among all the four, your paper is rejected. Copying abstract in the cover letter is going in the path of suicide. Yeah. So at this point, I'll not be surprised if some of us are thinking, what will be right? Finally, it's the same paper. I have to figure out a way of writing these four things differently. See, the purpose of abstract is to provide a summary. It is a summary. The purpose of conclusion is to tell your audience what is it that we learned. It is not a summary. The purpose of introduction is to provide background and summarize the result. The purpose of the cover letter is to tell the editor what is most important. So there's a little bit of overlap with the conclusion and what is the impact. Okay, maybe there are some examples. Yes. So this is a template, an example. First of all, you have to address the editor-in-chief, associate editor directly and correctly. I think it's a bad idea to write dear editor. I find it to be very impersonal, even though in some journals, that's how they do it. Now, a really bad faux pas would be you submit to this journal, I think it's ACS-AMI, write dear Professor Bartosi. Then they reject it. Then you submit it to ACS Omega. And your cover letter goes as dear Professor Bartosi. And it goes to Professor Ganesh. He will not be, he may be magnanimous enough to ignore it. But I mean, come on, we are dealing with human beings. Right? Let us not make them feel bad. So pay attention to transferable submission. Please change this. It is better to take the name. And I don't know whether it's correct or not, but they have also written it like this, PROFESSOR. My PhD guide used to get very mad if you wrote prof dot because he thought it's not sufficiently respectful. I don't quite get it, but I mean, it's better to play safe, right? Better to be safe than sorry. So this is how you should write. If you wish to submit, I mean, please don't copy this format, write it your way. But the point is, to start with, you should write the title of the manuscript and which journal you're submitting. Again, pay attention to transfer submission. Then you should say, what is it? What is your claim to fame of the paper? What are the main findings of the work? And then explain why that this paper should be published in that journal. Why this journal provides the best audience. Don't just say that I think it will be good for your readership. That is wishful thinking. You have to see what they have written. The work should be of interest to the broad audience that ACS Central Science wishes to reach, or this is ACS Central Science, not AMI. It touches on evolution, how new enzyme activities can appear and be improved through evolution, as well as inorganic catalysis, biocatalysis, and chemical synthesis. Says everything, right? But another thing, your letter to editor should be no more than 1 page in a reasonable size font, basically. So to summarize, the checklist that you should see is, while submitting a paper, is the title sufficiently appealing to a broad readership? Does the abstract contain the significant findings? Does the introduction tell the story of why the study was performed? Or is it just to start saying Einstein had done some great work and he had said E equal to mc square? And then you go on to write a paper on organic synthesis. Just giving some arcade example. But is it really something that provides a motivation for the actual study of performed? The figures and schemes, first of all, scientifically correct. And secondly, do they look good? That's also very important. Is it within the scope of the journal? The discussion we have made, is it sometimes we tend to digress and talk about things that are very interesting or something we have not done. Let's not do that. I've had that problem with several students. They do something, they learn something new, and they are so happy about that they keep them that, see, you cannot write this in results and discussion. These are not your results. Somebody else has done it. Put it in introduction. They provide a scheme there if you want, but be very careful. Acknowledgements are very important. You have to acknowledge funding agencies. You have to acknowledge anybody who has helped you in conceiving the paper, but is not an author. And here, even though it's not written, let me also say, authorship is also an important issue. Sometimes we see cases where somebody who should have been an author is not given authorship. That is just horrible. We are scientists. We cannot be mean people. So let us make sure that we give credit where it is due. Not only in acknowledgement, but also in authorship. Okay. And last one is also very important. Have all co-authors seen and commented on the final draft? I know of labs where the paper goes out from the professor's office without the students even seeing it. They just make the figures and whatever they write out. That's bad practice. We are scientists, not slave drivers, right? Our job is not only to do good research, but also to prepare the next generation of scientists who are like us or better than us. So involvement of everybody who's an author is very important at all stages. That's what I wanted to say. I think I'm just on time. Thank you very much for this opportunity. And sorry once again for the rescheduling.
Thank you, sir. I request if anyone have any questions, can ask.
Good afternoon, sir.
Good afternoon. Yes,
Sir,
Dr. Kanda, go ahead.
Yes, okay, sir, in your figure, you have shown that image without using any horizontal vertical axis notation, time is and that area.
Which one are you talking about?
Yes.
Yeah.
One of the important things, this image you have generated by is a GNU plot or?
This is not my image. It is from your JFISChem-led to 2014. So I don't know the answer to your question, but this kind of image can be generated using, we use Origin Pro. So Origin can give figures like this.
One of the important things, sir, here we are not giving the time axis in computer. I am from computer science, that we are using the arrow, horizontal direction, and also vertical direction. ABS at that.
So you're saying something like this? Hold on.
Yes. So it is in
what did I do?
Yes, sir. So here
so you're saying why have we
not using that?
Why have they not given an arrow like this?
Yes.
That was the convention when we learned how to plot graphs when we were in school. But now you see, the thing is, those were the days when everything was hand drawn, right? Now, for computer generated images, without the arrow, there is no value reduction. So it's okay. You might want to show arrows to show trends. For example, here, if I had drawn this figure, I would have perhaps drawn an arrow like this. Why? Because you see A, B, C, D, E. There is a turnaround. So an arrow like this would have made the figure even better, in my opinion. Yes.
And good. Sir.
Any other question?
Thank you, sir. It was very interesting, insightful, and learned so many things. I think we all are from different disciplines, but we still can use the learning that we had today. Thank you so much.
Thank you.
Thank you, sir.
Okay. Bye-bye.
Bye-bye.
I would like to take the privilege to thank all the eminent speakers for the day, for sharing their experience and knowledge with us all. Thank you all for joining today. I request everyone to join tomorrow at 11 a.m. again for day 3 of this faculty development program. Please join through the same link that was generated today itself. Thank you so much.